everyone. Welcome to Developing Intelligent Bots from Zero to Hero course. My name is Sharif Al-Mahdi. I work for Microsoft as a technical evangelist, and joining me in the studio, Sarah Said.
Hi guys, my name is Sarah Said. I'm also a technical evangelist at Microsoft. We both work for the team Developer Experience, and we actually traveled a long way from Egypt to South Africa to shoot this course.
Yeah, the main objective of this course is to walk you through the whole journey of designing, developing, testing, and deploying intelligent bots using Bot Builder SDK for .NET and Azure Bot Service as well. We'll be also covering Azure Cognitive Services as we are going to use it to make our bots smarter. Our course consists of 4 modules. In the first module, we will have an introduction to the Microsoft Bot Framework and Azure Cognitive Services. It's where we get to know what is the bot, what are the main pillars of the bot framework, and the development lifecycle of the bot. In the second module, we'll move to have a closer look on the Bot Builder SDK for .NET as one of the main pillars of the bot framework. And then we'll move the focus to the designing part where we talk about the bot patterns in module 3. And finally, in the last module, we will explore together Azure Bot Service.
The main target audience for this course are developers. If you're new to the bot framework, Azure, or cognitive services, no problem at all. We'll be walking you throughout the whole bot development journey from zero to hero. Regarding the prerequisites, all what you need to be familiar with before watching this course is web development, C#, some cloud computing concepts, and using the REST API. And most importantly, loads and loads of coffee so you can follow up with us by applying what we will cover in the demos. In order to do that, you will need, in terms of accounts, an Azure subscription, a GitHub account, and a Microsoft account. We will actually be using the Microsoft account to log into the Bot Framework Developer Portal and the Lewis Portal. So if you don't have any of these, you can navigate to these links to create yours. As for the tools, please make sure to download and install Visual Studio 2015 or higher, GitHub Desktop, the Bot Emulator, the Bot Project Template for Visual Studio, and also the Bot Builder SDK. For the template and the SDK, you can actually keep those aside as we will be doing this throughout this module together. You will find all the source code of the demos on this GitHub repo, and you can also download the slide decks and find out about our Q&A sessions from these links.
Great, so let's start the first module. The first module mainly consists of 2 parts. The first part focuses on getting started with the bot development using Microsoft Bot Framework, and the second part is more into bot intelligence using Azure Cognitive Services. And as you see, the module is full of demos so that we can show you how to build, test, debug, and deploy your first bot. Before digging deep into the bot development, let's understand first what is a bot. So Sarah, can you tell us more what is the bot?
Bots are the new apps that interact with the users in a conversational format. So here, the human language is the new user interface. Bots can communicate with users conversationally, either with text, cards, or speech, through any IM channel like Skype or Facebook. These conversations can be designed to be either in a free form or where intelligence is infused in all the interactions, or to be more guided where users have choices and actions. From a technical perspective, it's a web service. So now we know what is a bot. But Sharif, can you tell us what do I need to build a bot?
Yeah, as a developer, in order to build a bot, you need 4 things. The first thing is basically basic I/O, input-output in a conversation format with dialogue skills. The second thing is connection with the user's preferred conversation channel like Facebook and Skype, Microsoft Teams, or any of these channels. The third thing is, since a bot is a web service, you need a place to host your bot. And the fourth thing is mainly some intelligence services so that you can make your bot smart.
Standing on this, the Microsoft Bot Framework was introduced as a platform for developers to build, test, connect, and deploy their bots. The platform mainly relies on 3 pillars: the Bot Builder, the Bot Connector, and the Developer Portal. Throughout this module, we will explore each of them.
So let's start with the first pillar, which is the Bot Builder. As we just mentioned, the bot is simply a web service. So you need some conversational skills to use while developing your bot. And that's why the Bot Builder exists. The Bot Builder is simply an open source SDK that enables you to develop your bot by providing some features that makes the interaction between the user and the bot much simpler. And it provides features like messages that can be exchanged between the users and the bot, dialogues to manage the conversation flow, form flow to automatically generate dialogues for the more guided conversations, and in addition, it provides access to the bot connector. The Bot Builder SDK is available in two languages, C# and Node.js. However, for the other languages, you can still use the Bot Builder REST API. One more cool feature that takes place under the umbrella of the Bot Builder is simply the state management. The Bot Builder SDK allows you to store and retrieve the state data of a specific conversation or a user that can be used for many purposes later, like returning or greeting a returning user or saving the preferences of the user or the conversation.
The second pillar of the Microsoft Bot Framework is the Bot Connector. The Bot Connector sits between the Bot Web Service and the channels that the users use. As you can see here, the Bot Connector acts as the man in the middle that passes the messages between the bot and the users through the channels. It also normalizes the messages that the bot sends to the channel if necessary. It converts them from the Bot Framework schema into the channel schema. But the question here is, how does the bot access the Bot Connector?
The Bot Connector provides a single REST API to enable your bot to communicate with. So in order to send a message from your bot to the connector, you must get an access token from Microsoft Account Server. However, if you are using the Bot Builder SDK, the connector library enables access to the connector. So all what you need to do is to configure your bot with the app ID and the app password, and you get those when you register your bot. As for the channels, Microsoft Bot Framework supports several channels that you can connect your bot to, like Facebook, Messenger, Skype, Microsoft Teams, Slack, Bing, and Cortana, and more. But what if I have my custom own channel? So for example, if I'm building a mobile app or a web app that I want to have my bot connected to. In that case, you will need to use Direct Line API, which is a simple REST API that allows you to connect your bot to your own client applications or web chat controls or even mobile apps. On the other side, you can still embed a web chat control into your application so that you can talk to your bot from. In Module 3, we will be using the web chat control as part of our demos. So for now, we just have two ways to connect to any custom channels, the Direct Line API and the web chat control.
In order to be able to test and debug your bot web service, you need to download the Bot Framework Channel Emulator. The emulator enables you to chat with your bot. It also displays JSON logs on the side while chatting to your bot. If you're using Visual Studio Code, you can also use the debugger included to also test and debug. So now let's talk about the third pillar of the Microsoft Bot Framework. The third pillar is the Developer Portal. The Developer Portal is the one-stop shop to register your bot, that you can acquire the app ID and app password that ensures you that your bot endpoint can be only accessed through the Bot Framework connector. Also, through the portal, you can configure the channels that the user can use to chat with your bot, where each channel has its own unique configuration. Also, like any user, the bot has a profile that carries the bot profile picture, some description, and a handle. And all of these are manageable through the portal. The portal also provides diagnostic tools and web chat that you can use to chat with your bot once you set its messaging endpoint.
Now let's start building our first bot. In this demo, we will be exploring the anatomy of the bot project template, run our bot on the local server, use the emulator to debug our bot, and finally register the bot to acquire an app ID and app password. First of all, you need to download the bot application template from this link. And then once it's downloaded, you can put it here as one of the project templates here in this path, as one of your Visual Studio project templates. Once it's downloaded and you put it here, you can start easily go to Visual Studio and create your first bot. As once you have this application template, you can find the bot application template as one of the choices you have in Visual Studio under the C# language. Again, the Bot Builder SDK is available for the C#, not all the .NET languages. So let's start creating our first bot. Let me put it on the desktop, and let's name it as Hello World. That's our first bot. Now our project is created, and the project is basically a typical Web API MVC project. And you will realize that your project structure will be different than mine, as your project structure will contain a folder named dialogues here, since I'm using the old template for simplification till we explain the dialogues in the next module. So in Module 2, we'll be focusing on the dialogues and the activities, and we will have a closer look on the botbuilder.net SDK. But for now, if you can see here in the web.config, you can assign the values of the app ID and the app password once you register your bot from the developer portal from the web.config as part of the configuration of this project. And if we can have a look on the messages controller, we will see that it includes one core function, which is the post function. And the post function is the core function that takes messages from users and create replies. The function simply starts with creating an object of type connector client, as it defines a connector client by passing a service URL of the channel, which is simply the address to send the activities back or the messages back. Each channel has a unique ID and a service URL. You will also realize that your class is decorated by bot authentication attribute, and this attribute will help validating your bot credentials while accessing the connector over HTTPS. Now let's run our first bot. Basically what this bot does is it takes the input from the user, calculate the length of this input, and reply back with this string you sent, this text which was of X characters. So now we are having this running on the local host. I can now get back to my emulator, put the endpoint URL as this. So using the local host, I will add API/messages to have the message controller. I don't need now the API, the app ID or the app password, since I'm running this through the channel emulator, not a real channel. So let me connect and see here what will happen. Now it's connected. So if I can start chatting with this bot by typing hey, the bot will reply saying that you sent hey, which was of 3 characters length. Now you see here that the warnings that the bot is using an SDK version. That's because I'm using the old template and the bot builder version 3, which is an old template. When we start explaining the dialogues and all the form flow and all the new stuff in the module 2, we'll be using the new version of the bot builder SDK. As we mentioned before, using the emulator helps us to debug our project. So you can easily get back to your project, put a breakpoint here, and start chatting one more time with the bot saying, hey, Mr. Bot. And you see the Visual Studio will be running in the debugger mode as the length is 11, and you can start debugging all of your source code here. So also, I can click on one of these messages and see the JSON that exchanges between the bot connector and your bot web service. So for example, hey, it's a message, and that's the JSON that we will dig deep into in module 2 to understand what the type of the message or the activity, what is the ID and the channel account, and all that bot builder SDK related stuff.
So now, after we created our first bot using the project template, we also used the bot emulator to test and debug our bot. We are now going to register our bot on the developer portal. So let's go here to dev.botframework.com. I've already signed in, so all I'm going to do is click register, and I'm going to give it some information regarding this bot. So here, as you can see, I can upload a specific picture that represents my bot, and then here I will give it a display name. So this is the name of the bot. So here I will write the display name. So it's going to be hello bot. This is the bot handle. So like any user, you either have a handle or a username like the ones on Skype or Facebook Messenger. So I'm just going to say module 1 bot. As for the description, you just kind of explain what the bot does. So I'm going to say, hey there, I'm hello bot. And here, for the messaging endpoint, I'm going to skip that, as now we're running our bot locally. And within this module, we will start hosting our bot, and we'll come back to the portal and actually input the right messaging endpoint. So now let's create our first app ID and app password. I'm just going to click here to create it. And once this page loads, we're going to start seeing the app ID and app password. As you can see here, the app name is the Hello Bot, as the one we registered in the beginning. We're going to take this app ID to save it, as we're going to use it in the configuration. I'm just going to put it here in a Word document, and then I'm going to start generating the app password and do the exact same thing. Just copy it and go back and input it here. Once I've done this, I'm just going to click OK, go back to the bot framework, and then just agree on the terms and conditions, and finally start registering. So now the bot is created. I'm just going to click OK. And now, as you can see here, we've registered the bot, we put all the information, and now it's time to add all the channels that we want to configure on this bot. So now we have, as you can see here, these are the two automatic channels that are added, the Skype and web chat. But we're going to leave this the same, as we're not going to test this bot right now. All we're going to do is go back to Visual Studio, go back to the web configuration, and as you saw here in the beginning, we're going to have to put the bot ID, and app password. So the bot ID here is the name that we used, which is Hello Bot. And now we're going to take these from here. So let's take the app ID, put it here, and then finally take the app password and put it here. And now we've done all the configuration necessary, and we've done the registration. So our next step is to start exploring our hosting options for our bot. So we can come up with a running messaging endpoint to be able to connect the bot to one of the real channels and not just the emulator.
To host and deploy our bot, we have different options. The first one is the local host, the same as we saw in the demo, and it's mainly used in the dev and test. The second option is to use Azure App Service, or mainly API apps, as we are going to see in the next demo. And the third option is to use Azure Functions or going serverless, and that will be the way to go when we talk more about the Azure Bot Service, and we'll discuss this in details in our last module. And we definitely have different options, like going for just having a virtual machine, that having your web service up and running, or maybe other cloud platform. So now let's start the second demo to see how can we deploy our bot to Azure App Service on API apps.
So now let's deploy our bot to Azure API apps. So I'm going to go here. As you can see, our bot is actually running locally. So we need to change that and actually run it on the cloud. So what I'm going to do here is I've actually logged into the portal, which is portal.azure.com. And I'm going to start creating a new resource group. So I'm just going to click here. And then just write resource group. I'm going to click resource group, then create. And then I'm going to start giving it some names, just to have this resource group as the container that will have our API app that will be hosting our bot. So I'm just going to call this resource group Hello Bot Resource Group. And then let's keep this, oh, I think I missed this, so there shouldn't be any spaces. So I'm just gonna host this maybe in, let's say, West Europe, and then I'm gonna click create. So now let's go to the resource group we created. This is the one we just created. And then let's add here and create the API app that we will be hosting it on. Let me just type here API app. As you can see here, I'm just going to select it. select this as well. This is the API app we want. Click create. It will also ask me for some information. Once I've given it this information, I will start creating it. And then we will change the endpoint to see if it's actually going to run on this API app. So I'm going to call this also Hello Bot, since we're doing this API app. And then I'm going to use the existing resource group that we're on right now. This is just the plan that this API app is running on. And all I'm going to do here is start creating it. So this is going to go through some validation. Once it's created, as you can see here, it's deploying right now. I should get a notification here showing that it's created successfully. As you can see here, the deployment is actually successful, and now we have the API app ready for us to use. So let's go back to Visual Studio. And as you can see here, the project we have, we just want to publish this to the API app that we created. I'm going to right-click here, select Publish. So once I clicked Publish, as you can see here, from the settings, it's using the web deploy with the server name and the site name that we've created. And it's going to this destination URL. So we're just going to have the configuration on debug. Click Next. And save. And then we're going to click Publish. And this is going to start publishing to the API app. So once this is done, rather than having the bot running locally, we should then see the bot running on the API app with the URL that we created. So as you can see, now our bot is actually running on hellobot-api-app.azurewebsites.net, the one that we used here. So what we're going to do now is take this URL and go back to the developer portal and just select our bot and change the messaging endpoint that we had before to this existing one. So what we're going to do here, just paste it, but we're going to have to add an HTTPS, and I also add API/messages, and then just click Save Changes. So we saved these changes. Now we can actually test this bot on the channels we configured. We can go here and test it just in the web chat. So let's say hi, and see, as you can see here, it says you sent hi, which is 2 characters. This is just a web chat, but we can also go here to the channels and test it on Skype. So now I'm just going to add our bot to the contact list on my Skype account. I'm just going to click here, add to contact. Yes, I do want to go to Skype. And you can see here our bot, and I'm just going to click add to contact again. And now I can actually just test the bot on Skype. So let's say, hi there, Mr. Bot again. And now it actually replied saying you sent hi there, Mr. Bot again, which is 21 characters. So what we did so far is we've built our first bot and we ran it locally. We also tested and debugged our bot using the emulator. We then deployed our bot to Azure API app, and then we connected it to Skype, which is one of the channels. And now let's have a look at the bot intelligence.
So when we mention the bot intelligence, we should start talking about Azure Cognitive Services. Azure Cognitive Services is mainly a set of services that falls under 5 categories: vision, speech, language, knowledge, and search, where a lot of services that can be used to and be consumed as well from the bot to add bot intelligence are here. So for example, we'll be using the Language Understanding Intelligence Service, which is LUIS API. We may also use the Bing Spell Check. It's one of the APIs that check the spelling of the sentence that it took and returns the JSON with the right suggested sentence. So now let's take a look and a quick tour on the Azure Cognitive Services. Then we'll focus on LUIS, which is the Language Understanding Intelligence Service API. Now let me get back to Edge and navigate to this URL. If you see the cognitive services URL, azure.microsoft.com/enus services, cognitive services, and from this page you'll find a lot of documentations and code samples and the pricing details about all of the services. So if you scroll down here, you'll find the 5 categories that we talked about, the vision, and then the services that fall under the vision category, speech, and the same language, knowledge, and search. So for example, let's try fiddling with 2 APIs like the emotion API. It's one of the coolest API that it's under the cognitive service. So for example, this API allows you to detect the emotion of the people in the picture. So you can upload your own image and try it by yourself, or you can use one of these examples to check. So for example, here it detects 2 faces and it gives scores to the emotions suggested, like the anger, fear, happiness, neutral, sadness, and surprise. So that's one of the APIs that you can use from the cognitive service. I think one more API that I really like is the spell checking API. So if we come here to the language category, we can use the Bing spell check API. So if I say here, I'm currently, let me write currently, not right, shooting one more course. So you see I have some spelling mistakes. If I click submit and check, the API is getting me, I'm currently shooting one more course. You can see also the JSON here with the score based on the suggestions retrieved of the Bing spell checking API. So feel free to explore the rest of the APIs, read the documentation to know how can you consume these APIs into your applications. And I think some of the APIs offers SDK that you can get use of as well. Now let's get back to our presentation and talk more about one of the most important services that we are going to use a lot while developing our bots, which is Language Understanding Intelligence Service, the LEWIS API. LEWIS mainly enables you to understand the input of the user and while talking to the bot and react accordingly. So the LEWIS app is a place for a developer to define a custom language model based on the keywords that matters to the user based on the bot scenario and the bot main goal. The output of a LEWIS app is a web service with an HTTP endpoint that you can consume from your client application. And by the way, this is not a mandate. It's not a mandate to consume LEWIS API from your bot. You can consume it from your mobile application or web application. Also, it's the same for the rest of the cognitive services. So let's have a closer look on LEWIS to understand how it works. Simply, LEWIS takes the sentence you write or the user writes, whether from the bot or any other application, do the processing and returns JSON based on the HTTP endpoint that you consumed. So the JSON comes with intents and entities. So let's understand what is the intent, what are the entities, what are the utterances that we can use while training the model, and how can we get started with LEWIS app to start building the intelligence of the bot. The intents are mainly representing the actions that the user wants to perform. It's kind of the purpose or the goal of the user's input. And the entities are the instance of a class relevant to the user intent. So for example, if I'm saying book me a flight to Cairo, so book a flight is an intent and Cairo is an entity of type location. But what about the utterance? The utterance mainly represents an example of the user query or command that the application is expected to receive. So for example, we have here on the screen, we have 4 utterances like book me a flight to Cairo, order me 2 pizzas, remind me to call my dad tomorrow, where is the nearest club. All of them are utterances where each one contains intent and entities. So for example, for the second utterance, order me 2 pizzas, order me or order is intent, pizzas are entities as well. While you are building your LEWIS app, you may use the phrase list features and the button features to improve your LEWIS performance when it comes to the detection of the entities and the intents. So for example, the phrase list feature, it's kind of a list of values that falls under a relevant entity. So for example, if I can put one of the values in this phrase list is the city, and I can put under the city Cairo, Paris, London, New York, a lot of cities that I can include under this value. That's when it comes to the utterance number 1, which was book me a flight to Cairo. So if the Lewis app detects one of these values, it treats them similarly to the rest of the others, so that you can train it with one value and it will apply with the other values. As for the pattern features, it's kind of the regular expression. So for example, you can put a pattern feature as a regular expression for the flight number. So using the phraseless features and the pattern features may improve the performance of your Lewis app. Now let's build our first Lewis app. In this module, we'll see how to create a Lewis app, publish it to Azure to come up with the HTTP endpoint that can be consumed later from our bot applications or any other application. So in module 1, we will just build the Lewis app. In module 3, we will be having a lot of demos regarding the bot buttons, and we'll be consuming Lewis applications or Lewis endpoints in our bots. So let me get back to my browser, Edge, and navigate to lewis.ai. And once you sign in, you will be able to create your new application. And if you have any applications that created before, you will be seeing this in this list. So let's create our first application. The Lewis app will be named Hello World, or maybe Hello Lewis. Make sure that someone didn't take it. And I will skip the endpoint key till we publish this app to Azure, so that we can come up with an HTTP endpoint that can be consumed from the bot we are going to build. Now, I have my application created. Let's open the application so that we can start adding intents, entities, start the training phase, and do all the related stuff when it comes to the intelligence. So here's the application ID, and I can start add intents by clicking on the intents and click add here. So let's assume that we are building a custom language model for an hotel booking bot. So my first intent will be related to booking a room. So maybe I write it, book me a room in hotel. And this is a very generic one, as it doesn't include any entities. So book me a room or book a room is the intent, and there's no entities here. So let me save this as an example utterance for this intent. I can add a lot of utterances under the same intent for training. And then I can move to entities and start adding custom entities. So for example, the entity here may be the hotel name, so I can have this entity as Hilton, for example. And the entities have types. Let's go for the simple type for now. Let me add it, and now I have Hilton as one of the entities. Let's get back here to the intents, and I will see my intent here, book me a room. Let's start typing some utterances with intents to be able to train the model. So I can say, book me a room in Hilton. And once I add this to the intents, I can come here and say that this Hilton is the Hilton entity. That's the list of the entities I have. So I can mark it here as part of the training that will be happening after I finish adding intents and entities. So you see, you can use this intents tab to add more intents. Like for example, I can add one more intent, like greeting intent, and maybe the utterances here will be hi, that's one, and there's no entities here, or hey. That examples of the user's commands or the queries. And when you publish your Lewis app, the real user commands or queries based on the applications that is consuming your model will be appearing here in the suggested utterances. So in this tab, you will see some end user queries based on the application endpoint once the application is published. So that's how you can add entities, and you will find here some pre-built entities like the age, the date, dimension, email, the generic entities that can be detected whatever the nature of the application is. Let's move forward and try to explore the features. As you see here, under the features, we have the phrase list feature and the pattern feature. The pattern feature is the one who I can set under the regular expression, like the regular expression for a booking number or flight number or something like this, that I want to be able to detect from the user input. On the phrase list feature, it's kind of I can add some values under a specific list name. So for example, if I want to get back to the example of the hotel booking Lewis app, so I can have a list of the hotel, and maybe I can add a lot of hotel names like Marriott, and here I can add a lot of values like Hilton and the rest of the hotel names. Once the Lewis app will be able to detect one of these values, it will treat the other values the same. So once I'm done with this, I have to start training this Lewis model with a lot of utterances. Definitely 1 or 2 sentences are not enough or not sufficient for training your model to be intelligent and to be accurate. So you may go for batch testing when you upload a data set with some of the utterances that can be helpful and diverse to train your application, or maybe you can just train interactive testing by click train this, and it will take the utterances that we just entered under the intents tab and start training your application. So the training has been completed successfully. Once we are done with the training, you now want to publish your application to come up with an HTTP endpoint that can be consumed as a REST API into your bot or any of the applications that you are going or you want to consume this Lewis app from. In order to publish your app, you need an endpoint key that you can acquire from your Azure subscription. Once you go to Azure subscription, open it and create Azure Cognitive Services and select Lewis, as we're going to see now. It gives you an endpoint key that actually that's the endpoint of your Lewis API to be consumed from your application. So now we need to move to Azure and create Lewis endpoint so that we can come up with the key and add it here. So let's go to my Azure subscription and start creating our first Lewis app so that we can come up with the key. Let me click add and start searching by cognitive services. Yes, here it is. So once I have it in the search result, I can click on it to start creating a new one. So here's the cognitive services. Let me click on it, then click create. And while I'm creating, I need to specify that I want to create a Lewis API, not any other API. So let me give it a name first. Maybe it's Hello Cognitive Services. And the API type, since we have a lot of services under the cognitive services, I need to just pick the language understanding intelligence service. As you see, it's still in preview. And let me pick the location, maybe West Europe. It's preferred to choose the nearest data center you, and the pricing tier, I'll go for the S0, and use the existing resource group that Sarah used, which is Hello. But I think, yeah, she used the other Azure subscription. Let me create a new resource group. Let's name it Module 1 Resource Group, and let me confirm this to be able to create. Once the Lewis app or the Lewis or the cognitive services is created, I can get the key of my API so that I can add this key to my Lewis portal in order to be able to publish the Lewis app. So it's deployment in progress. Now it's succeeded. Let me get back to the resource group that we just created. Let's back to the list here and search for module 1. Yeah, if I can see here, yes, it's module 1 RG, module 1 resource group. Let me close this. And I will find that I have only one resource in this resource groups, which is the cognitive services. Yes, Hello CS, Hello Cognitive Services. Once I click on it, I can see here a tab named keys. And from this keys, I can get the endpoint key to be passed to the Lewis portal. Let me copy this, take copy, then get back to my Lewis portal and add a new key. Let me add a new key here. As you see, you can get one from Azure. That's actually what we did. Let me add a new key, name it, let's have the value here, and name it module 1 key. Let's save it. Yeah, once the key is added, maybe it's doesn't accept numbers, so module 1, let's write it like this. Let's save it again. Yeah, it sounds like the key is not accepted, so let me check what's happening. Let's get back to Azure and notice, yeah, it takes up to 10 minutes to take the effect. That's why it doesn't accept this key. So if I can come up here again after 10 minutes and click save, it will be able to recognize it. Now it's not able to. So once this key is accepted, we'll be able to publish the Lewis app and come up with the HTTP endpoint. In order to save your time, I already created a key before, that's Bootstrap key. So let's get back to my apps, Hello Lewis app, the app we just created, and let's publish and choose the key that I already created before. Let's train, and you can specify this endpoint is for production or staging. For demo purpose, I will go for staging. Then I will train this model that I can publish the app and come up with the HTTP endpoint. Now the training is completed. Let's click publish. And here's your endpoint URL. It's a REST API that you can consume it into any of your applications, whether it's a bot application or any other application. In Module 3, while covering the bot patterns, we'll be building 2 bots, and we will see in one of the demos how to consume this endpoint into your bot so that we can have the end-to-end scenario in Module 3.
So now let's have a bird's eye view on what we've covered throughout the module. We had an introduction about the Microsoft Bot Framework, which consists of the bot builder, the bot connector, and the developer portal. We had some demos to cover building our first bot, running it locally, and testing it on the emulator. And we actually deployed our bot to Azure API app. We connected it to Skype, which is one of the channels. And then we moved our focus to Azure Cognitive Services, where we built our first Lewis app. So if you want to read further, you can navigate to any of these links to find some more documentation, code samples, and the templates that we've used. You could also find here the links to the tools, so the Bot Builder SDK and also the bot emulator. Thank you so much for watching, and I hope to see you in our next module. Hi guys, welcome to the second module of developing intelligent bots from zero to hero. In this module, we'll be focusing on one of the main pillars of the Microsoft Bot Framework, which is the Bot Builder SDK for .NET. In this module, we'll be going through mainly the activities, creating rich messages, some of the dialogues, and managing state data, and also the form flow. In the first module, we spoke about the bot connector. The bot connector acts as the man in the middle that sits between your bot and the channels. Your bot carries your bot logic and is developed with the Bot Builder SDK. Your bot also communicates with the bot connector service using the connector library. But the question here is, what is the object that the bot connector passes between your bot and the channels and vice versa?
The connector uses the activity class to pass the message back and forth between your bot and the channel. So, for example, if the user is saying hi, an activity carrying the text message hi is transferred from the channel to the connector, then from the connector to the bot. And if the bot is replying to these greeting messages, another activity is transferred from the bot to the connector, then from the connector to the channel. And since the connector is the man in the middle, the activity class offers some properties to facilitate the role of the connector. So for example, we have here under the activity class, the from and the recipient properties to facilitate the direction of the activity for the bot connector service. So if I'm saying hi from the channel to the bot, the from will be the user and the recipient will be the bot, and vice versa in case I'm creating a reply. Also, we have 2 more properties related to the channel under the activity class, which is the channel ID to identify which channel I'm sending the activities back to, in addition to the service URL, the one we talked about in the first module, which is the address of the service endpoint that the connector will send the activities back to. In addition, we have the type of the activity and an ID, a unique ID identifying this activity. And the last one here is the conversation account that identifies the conversation itself. That's not all the properties under the activity class. You can navigate to this link to know more about the activity class and see and explore all the properties falling under this class. In the first module, we talked about the post function, which is the core functions that takes the messages and create replies. But we didn't dig deep into this function. We just explained the connector client and the service URL. Now in this module, we will get to know more about the activities and see how we can create replies and take this to the next level by creating rich messages. So if we get back by running this basic post function, which was the hello world bot that we created in the module 1, we will see that here, if we send hi Mr. Bot as greeting messages from the user to the bot, we will see that the JSON showing the properties of the activity class, we have an activity of type message, and from the user, then the user has an ID and name, default user, and name its user, and we have also the ID that identifies the activity itself. If we proceeded to see the reply from the bot to the user, we can see here that the from property now is the bot, and the recipient is the default user, and you can see as well that the conversation has a unique ID that identifies this conversation, in addition to the channel ID, which is the emulator, since we are using the emulator in the first module. If we took this further and put a breakpoint to see the activity which was sent from the user to the bot, the first activity as you see here in the source code, and we dig deep into this properties, so we find that the first activity, which is hi Mr. Bot, the first message that was sent, the from property is of type channel account, and the recipient property is of type channel account. So both of the bot and the user has channel accounts. Each channel account is of an ID and name identifying the user or the bot. Not just the bot or the user who has an account, the conversation itself has a conversation account. So as you see, the conversation account contains ID, the name of the conversation, and Boolean variable is it a group conversation or not. So all of these properties that we are debugging is under the first activity, which is hi Mr. Bot, the message that was sent from the user to the bot. But the post function contains two activities, the one from the user to the bot, and then we call a create reply method that returns another activity, and this activity actually is the one sent to the user as a reply. If we have a closer look on this reply activity, the one created from the create reply method, let's dig deep into this. We'll find that the attribute from and the recipient are swapped. So mainly what the create reply message did is that it just returned an activity with the same attributes when it comes to the conversation ID and that stuff, and just swapped the from and the recipient properties. So you find here that the from now is the bot, and it's of channel account type that contains ID and name, and the recipient is the user with ID and name of the user as well. So once the reply activity is ready, we use the conversations class and call the method named reply to activity to send this activity from the bot to the user. And the question is here, do we have any other methods under the conversations class to send messages or activities from the bot to the user?
Yes, we actually do have two cases. So the first case is to send a reply to a specific message that the user has sent to the bot. And the second case is to send a non-reply message, not to a specific message that the user has sent to the bot. So if you want to send the reply, like the one we just saw, you use under the conversation class the reply to activity. But if you want to send a non-reply message, not to a specific message that the user has sent, in this case you use the send to conversation instead of the reply to activity. So let's actually take an example for sending a non-reply message. To do that, let's say we want to start a conversation. So firstly, we create a user account, and this user account actually is the channel account, and it takes the name, which is Sharif, that's the user that we're going to speak to, with the ID number that you see here. So second, we're going to create a connector client, and this connector client will take the service URL. Then we're going to create a conversation using the create direct conversations method, and that will take the bot account and the user account. And this method will actually return the conversation ID for us. So next, we're going to create the activity using the create message activity. And like any activity, it needs from, so here it's the bot account, and the recipient, the user account that we're going to talk to. And then we're gonna give the conversation ID that we already created, and then give it some text so the bot has the text that's going to send to the user, and also give it the local, which is the language that the bot will use to speak to the user. And then finally, use the under the conversations class, the send to conversation, and give it this activity to send to the user. So here it will just say hello Sharif to Sharif, the user. Okay, great. Now we looked into some of the properties for the activity. We looked into the activity ID, the from, the recipient, the channel ID, and the conversation ID. Now let's actually explore the property type. So the activity actually has many types. Types like message, the one we used in our Hello World demo. We also have types like typing, that this typing indicates whether the user is currently typing a response or not. We have another type like the contact relation update, that shows if that bot is actually added or removed from the user's contact list. We also have other types like the ping, that kind of determines whether the bot endpoint is accessible at this moment or not. This, if you remember when we used the developer portal and we click the test button, that's exactly what that does in the beginning. It sees if the endpoint is running at the moment or not. We then have also other types like the end of conversation. It shows if the conversation ended or not. And lastly, we have a conversation update, and that shows whether any other members have been added or removed from this conversation. And we have many more that you can also explore and try out when you start building your own bot. So if we go back to our post function, we'll see that it starts by checking if the activity we received is of type message. And if that is true, it will just start calculating the length of the activity and just create the reply.
Now I think we have a better understanding of the post function, the one we used in the first module as part of the Hello World bot. Let's start seeing how can we create rich messages to reply with some rich content instead of just replying with text. Activities of the type message can be any of the following. We can reply with text, the same like what we did in the demo and the code snippets we just had. Maybe you can reply with media attachments, with photos or audio to be played, or some rich cards that contains text, buttons, or images as well. It's kind of a rich content that you can reply with. Maybe a suggested actions to the user so that the user can pick one of these actions, or maybe you can reply with speech or a channel specific data. In our next demo, we will try most of them. We'll try the text, the attachments, the cards, and the suggested actions as well. But before going for the demo, let's see what are the types of the rich cards. We have different types of the cards. We have an adaptive card that contain a combination of text, speech, images, buttons, and input fields. It's kind of a form with or a screen that you are replying with to the user. We have different cards as well, an audio card that can play an audio file, a hero card that's typically contain a large image with one or more buttons combined with the text, and we have a thumbnail card that kind of a single image with one or more text. It's different layout than the hero card. We can provide cards for specific use like receipt card when someone is purchasing something, or a sign-in card that you can enable the user to request a sign-in with this card. Maybe you can reply as well with a video card that can play videos.
So if you're replying with a card, you can have your message contain multiple cards. And you can do that using the attachments property, where it's programmatically a list of cards. You can also display your card using the attachment layout in two different ways, either the list or the carousel. the list is displayed vertically, while the carousel is displayed horizontally like the flip view. So as we said, the cards can have buttons, but programmatically, you will not be using the buttons, you will be using the card action. And the card action is used to process the events within the card on click. But if you're using adaptive cards, the card action will not be applicable. So the card action has four main properties. The first one is the image, which is the URL of the picture that will appear on the button. Then we have the title, which is either the text or the content, which appear also on the button. Then we have two very important properties. The type, which kind of defines the action implemented when you click on this button. And then we have the value, which is the parameter required to execute this specific action. So as you can see here, these are the list of card action types and their expected value. So for example, the open URL, it expects a URL that will be opened. Also the call, it expects the phone number to be called in this action. Also, for example, the download file. It also expects a URL of the file that you want to download. So feel free to go through these types and explore them while building your bot. So now let's create some cool messages. In this demo, we will be covering text, attachments, cards, and finally, suggested actions. Let's go back to the first bot that we created, the Hello World bot. So in this bot, we just use plain text. If we want to change and we don't want to use the plain text, we have to assign a value to the text format property of the activity. So the text format can support XML and Markdown. So let's just play around with this and see how we can do that. Let's delete these two lines here. And then let's start by having the activity and giving it the text format. And let's define this text format. Firstly, let's just try the Markdown. Let's go back here. Just missing a semicolon. Let's do that now. Then let's give this activity some text. So activity.text. And then let's actually put Sharif's Twitter account, since he's obsessed with having so many followers. And then finally, let's reply this activity back to the user. So I'm going to do activity, reply, and this specific activity dot create reply, and give it the activity that we just created dot the text that we just gave it. So now before we go back and actually run, let me just add the assignment operator, as I actually missed it the first time. Now let's just run here. Once this runs, I can go back to the emulator and test what I just did. So now this is running. Let's go back to the emulator here. Connect to our local host. I just put the app ID and app password that I created on our first module. I'm going to connect. And once this is connected here, I'm just going to test this. So let's try connect again. Perfect. This is now connected. Let me just say hi. And then as you can see here, what we did in the Markdown, the Sharif's Twitter account with the link is now working. So now that the Markdown is working, let us just try and fiddle around and maybe try going back here and changing this rather than having it as the Markdown. Let's go and change it and make it into the text format, change it to the XML. So let's just copy this. And let's just comment this out. And let's just change the text format instead of Markdown. Let's put XML. And then rather than having Sharif's account, let's just say, for example, hi, Mr. Bot. Let's make it bold first. Hi, Mr. Bot. Let's close the bold here. And then finally, let's actually try this out. I think we missed something. Oh yeah, I missed the quotations here. Now let's run it and see how this is going to come out. Now it's running. We'll go back to the emulator, refresh the connection. Let's say hi, Mr. Bot. And then as you can see here, it just said hi, Mr. Bot again. Before we move on to the attachments, I just wanted to let you know that with the text format, you need to make sure that the text format you're using is actually supported by the channel the user will be using, as not all the channels actually support these formats. And if they're not supported, the bot connector will try to map it to the closest format supported by this channel. So now let's create our first reply activity with an attachment. Let me just comment this out here. And then let me create. Let me go back here, create a new activity object. And then this activity, let's give it a reply. Or let's call it reply. And then this activity also .create. We have to create the reply. And let's give it some text. So let's say, for example, replying with an attachment from the back scene. Let me go a bit here. And then once I've given it the text, I need to then say reply dot attachments is equal to a new list of these attachments. And let me give it the right type. So here this list is going to contain an attachment. And finally, let me just give it the right brackets. And lastly, this reply dot the attachments dot add, as I want to add a new attachment. So I'm going to say here new attachment, and then let me just remove this. Go here, and then this attachment needs firstly a content URL. And this content URL, I'm going to go back here to Edge, as I have a picture I've taken from the back scene. I'm going to take this URL, go back to Visual Studio, just paste it here. Then I need also a content type, as there are different content types here. So I'm going to say that this content type is an image, and it's also a JPEG image specifically. And then lastly, I just need a name for this picture or image I'm using. And I'm going to call it from the back scenes .jpeg. Now I'm just missing one more bracket. And let us run this to see what the outcome. Once this is running, I'm going to go back here to the emulator, reconnect. Once it's connected, I can now test it. Let's try, make sure. Perfect, it's connected. Let's say hi. And as you can see here, now I got the text that I assigned it, and also the attachment which I got from the URL.
So we just saw how to use the attachments while creating message activities, and we also saw how to change the text format into Markdown and XML. Now let's try using the cards. As you know, we have a lot of card types, like the hero card, the thumbnail, the adaptive. Let's try 2 of them. I'll go back to my Visual Studio and see again, here is the first state of the Hello World project. the one we created yesterday before the modifications that Sarah did for the text and the attachments. And I'm gonna delete this and start creating our first card. Good. So in order to create a card, let's start creating an activity, a reply activity, by using the create reply method, the one that swaps the from and the recipient. So I can come here, create an activity named reply, then this activity will be created as a return object of the create reply method, and here's the text. I will do maybe 2 cards, one showing my GitHub account and the other one is showing my Twitter account. So here's my GitHub and Twitter accounts. Let me start first by assigning the attachment layouts. That's how the cards will be displayed. So I can come here, say reply.attachment layout, and in the attachment layout I have 2 options. The first option is the attachment layout types dot. I have the carousel and I have the list. The list is kind of a vertical display, and the carousel, it's kind of an horizontal flip view. So I can go for the carousel at the beginning. And again, since I will have multiple cards, I need to initialize my list of attachments. So I will say reply.attachments equal new list. Yes, let me define a list of attachments. Yes, as you see here. And let's finish my initialization. Again, it doesn't include my namespace for the generics. So now I can include it in my solution. Once I have this, so now I can start adding the cards to my attachments. And each card contains 2 things, images and buttons, actually beside the text that we just initialized. So in order to have the buttons, as we mentioned before, we use a class named card action. So I'm going to create my first card action, which is the button that navigates to my GitHub account. So let's name it GitHub account, and I will say new card action. And this card action expects 2 things. The type of the action that will be executed. As you see, we have different definitions for the constructors. The second one expects the type, and you see the title and as well the value. So we have different things, the type, the title, the image, and the value. So I can start with the type, which is open URL, since this will navigate to my GitHub account. And then I can give this card a title, just my GitHub account, and I can assign image to this. Maybe I can leave it for now as null, since I don't want to show any image on the button. I will show an image in the card itself. And the last thing it will take, which is the GitHub account URL, so https github.com/Sharif El Mahdi. Now I have the URL. So I have my first card. In order to be able to have a rich card, I want to add an image to this card. So I will be using a class, I will be initializing an object of a class named card image, and that will add an image to my card. Once I initialize the object of the card, I will start by initializing an object of hero card type. So I can say here GitHub, let me write it, GitHub logo, and then I will start initializing this with a new card image. And the constructor of the card image expects the URL of the image, the alternate of the image, and maybe a card action. For now, we just want to have the image of the URL of the image. Here it is. Let me add this quotation. Yes, that's the URL for an image that has the logo of GitHub. So now I have the action. I have the card action. I have the card image. So I have a button and image, but I didn't initialize the card itself. So we're going to start with the hero card. And this hero card, I will name it GitHub card. Let me initialize it using the default constructor. Then in this GitHub card, I want to add to the buttons my action card. So I will add it. That's the GitHub account, which is the action card. Maybe can add as well in the same card, under the images list, I can add my card image, which is GitHub logo. Yes, let me write it like this, GitHub logo, hub logo, good. So once I have this, yeah, it seems like I have an, yes, let me add it here. Now it's right. So I just added the button and the image to the data card. My next step is to start adding or assigning values to the rest of the properties of the card, like the title of the card. Maybe you can have a title like my GitHub account. One more thing I can assign is, we can, for example, assign, as you see here, subtitle. Feel free to assign any of the values. You can not to assign them as well. Once I have this property and the card is ready and the image and the button are added to the card, I can get back to the attachments, to my attachments, yes, and start adding my GitHub card to, let me cast it to attachment, yes. Now let's run this. My bot should reply with card, hero card that contains a link button that navigates to my GitHub account, the image that has a GitHub logo. Let me open the GitHub, sorry, the emulator. Yeah, it's now running. Once the emulator runs, I'll be able to test this. Yeah, here. The emulator is running now, so let me connect, yes, and start chatting with the bot by saying hi. Yeah, you see we have an exception here. Let's get into this exception. We have a null reference exception, so maybe one of the object is not initialized. Let me stop this. Yeah, if you can see here, we are adding to a list that is not initialized. So I need to come here, GitHub card dot buttons list, new list of type card action, and I should do the same with the images list. So if I can come here, copy, paste this, but change this into images, and this should be card image. Now you should be able to have this running. Let me run it one more time. Yeah, we have the emulator running this time, so I connect again and start chatting with the bot. I expect it replies with a card, and this card, yes, here you go. Here's my GitHub and Twitter accounts, and that's the card image, the card action, and the title of the hero card. Now let's add one more card of different type to the list of attachments, and it should be displayed in the carousel view. So let's get back to Visual Studio, stop this, and add one more card. In order to have a new card, we need one more button, one more card action, and one more card image. So let me start this time with a card image that will carry Twitter logo. And so it's logo, yes, just say new card image and paste the URL of the Twitter logo. And then I want to have one more card action. Let me copy this, get back here, and change it to Twitter account. That's my Twitter account, and again, this action is still of the type open URL. You can definitely explore other types like the call or the download file. So I'm using this open URL action, and I will put here my Twitter account. Yes, good. So I have an image, I have a card action. Now I want to start creating the new card. Let's start with creating other type of the cards. Maybe we go for the thumbnail card and name it Twitter card. Let's initialize this card. And then in the Twitter card, we again have the buttons, and we have as well the images. Both of them are lists. Buttons are list of card actions, and images are list of card images. So I can come here and take this, copy. Yes, that's the buttons and the images as well. Now I have the lists initialized so that I cannot get exception like the one before. And this Twitter card, I can start assigning values to the properties we have. So in the buttons list, I can add my new card action, which is the Twitter account. And in the Twitter card, I can come here, again adding the images by adding the Twitter logo image. Yes, here we go. My next step, maybe I can assign one more value for the Twitter card, which is the title. It's same like the hero card, I can say here, but the sizing of the card will differ, as you are going to see when we run this. So I can say here, here's my Twitter account. And once I have this card is ready, I can get back here, same as we did with the hero card. I can get back here to the attachments of this reply and add one more card. Yeah, if you see hero card, or maybe it's Twitter card dot to attachment. Let's do the casting, and now let's try run this and see what will happen, since the attachment layout is carousel. So I will run it again. Once I have it running on the local host, I can get back to the emulator and connect one more time and say hi to this bot and wait for the reply. Yeah, as you see here, we have, here's my GitHub and Twitter accounts, the text, and I have two cards. The first card is the GitHub one with the button, and the second one is the button with the image. The image is, maybe I don't have the right URL, but as you see, it's in the flip view. Yeah, here's the image. Yeah, now it appears, since it have a white space here. So here's the flip view. If you change this attachment layout from carousel to list, let me change it and try this one more time. Okay, here, come, yes, let me say hi again. You can see it's displayed in the list. We have two cards that are displayed in a list, not in a flip view. So after we tried the cards, let's try one more type of the activity messages. We can try the suggested actions. So let me comment this. I will comment this code. Yeah, come here. Let's change this. Here's my suggested action. Maybe if you can write it, if you are developing a bot that offers specific services or specific actions, the suggested actions will be useful. So maybe the bot can say, how can I help you? Then offer some actions for the users to choose from. How can I help you? Yeah, as you see here. And then I can say in this reply dot suggested actions, yeah, suggested actions. As you see, the Visual Studio cannot recognize this type, as the suggested actions are included in the Bot Builder SDK version 3.8, and we just have and we're just running this in the old template, so I think it's 3.1. So all what you need to do to get this type included is to get back to here. If you are not using the new template, go to the new package manager. You'll find in the update, and you'll find that the Bot Builder SDK needs to be updated. Yeah, as you see here, we need to run this 3.8.1 version. I will click update. Once it's updated, once I get back here, to be able to read this suggested actions. Again, the main reason I'm using the old template is that I didn't explain yet the dialogues. Once we explain the dialogues, we will walk through from the old template to the new template in this module to see the new template of the project, the bot project. Okay, so once I have this now, the suggested actions are readable. Let me continue by assigning or by calling the constructor of this suggested action. So here's the constructor, and I can not use the default constructor. We can assign some list of action cards, which are the actions that will be provided in the reply. So I can come here and say I want to define the list of the actions. So the actions here is of 2 card actions, maybe. Here's the list of the card action. Again, and like any card action, it needs to have the type and the value. So I can initialize or create my first card action, my first button, just button of actions. There is no cards here. I can say the title would be, maybe one of the options that will be offered by the bot is to open bot dev portal. Again, that's the title. I need to have a type for this action, which is, for this case, I'll be using as well open URL, like the one we did before. So if I don't want to hard code it, I can just come here and say action types, which is a better coding dot, and you'll find all the types of the actions. I will go for open URL, and the value, which is the expected parameter, will be the URL. So I can make it here, dev.botframework.com, and here's my first option or my first action. Maybe I can add one more action here. Yes, if I can copy this. Let me copy it to have 2 choices at least, and we can make it, yeah, if you see, it needs to have this semicolon. Yes, I need to remove this extra braces, and let's run and see how we'll reply with suggested actions. So we have build error here. Let me see what's missing. Unexpected thing. Yeah, maybe one here will fix it. Yeah, great. So let's run. Open the emulator one more time, but this time we're not expecting the reply to include cards. We are expecting to have some suggested actions. So I say hi, and the bot should reply with 2 actions. Yeah, how can I help you? And these are the card actions that we defined in our source code. So we just saw how to reply with rich messages using the cards, the text, the attachments, and the suggested actions. But in the real world, bots not just reply by one sentence, bots should be able to maintain a full conversation. So from this point, let's start talking about the dialogues. By using the dialogues, you can do 2 things. The first thing is to logically separate different areas of the bot functionality. So your bot may have different functionalities. The first one is to authenticate the user. The second one, for example, is to show the items list. The third one is to order the items. So you can logically separate the different areas of the bot functionality using the dialogues, in addition to guiding the conversation flow. So in the traditional apps, like the web apps and the mobile apps, the apps are made up of screens. As you see, you have a main screen that navigates you to the items list, that navigates you to the order item screen, and that's it. But on the bots, the screens are the dialogues. So for example, I can have the root dialogue, which is equivalent to the main screen, then the items list dialogue, then the order item dialogue. So let's have a closer look on how the dialogues work. So the dialogues operates in a stack. So we have the dialogues stack. At the beginning, it's empty till you initialize the root dialog, which is the first dialog. And by the way, when you install the bot project template, the new one, you will have a folder named dialogues, and you have the root dialog in it. Once this dialog is initialized and initiated, every message that will be sent by the user will be processed by this dialog till this dialog invokes other dialog, which is the item list, and now the item list dialog is on the top of the list, and every new message will be handled by this dialog till it's closed or it invokes another dialog. So if this items list invokes the order item dialog, it will be added to the top of the list, and this order item dialog will be handling all the messages and processing all the messages sent by the user until it's either closes or redirects to another dialog.
So the good thing about the Bot Builder SDK that it provides dialogue data types that lets you manage the conversational flow. So each dialog here is an abstraction that encapsulates its own state in C#. So as you can see in the root dialog class definition, the iDialog interface is implemented. Also, the Bot Builder SDK enables your bot to be stateless. This is why the dialog class definition needs to be decorated by the serializable attribute. So here, the dialog stack and the state of all the active dialogues are serialized to the iBot data bag in a key value format. So this serialized bag is persisted in the messages that the bot sent to and received from the connector.
Before we start creating our first dialog, let's understand first the dialog's key concepts. The first thing here is the method named sendAsync, conversation.send asynchronous, and that's the key method to implementing dialogs with the Bot Builder SDK for .NET. This method simply initializes the first dialog, then deserializes the conversation state from the iBot data store, which will be empty in the first time. Then it resumes the conversation process when the bot suspended waiting for messages. After this, it sends the replies and serializes the updated conversation and save it back to the iBot data store. Each dialog should define a start async method as one of the methods that is included in the class definition of this dialog, and this method should call the iDialog context.wait that specify what method should be called when a new message is received. And each dialog as well should be ended by a context.wait to suspend the bot waiting for messages that will be handled by this dialog in a specific, or if you want to close the dialog and remove it from the stack, you just end the dialog by context.done, or you may want to end the dialog by failing this dialog by calling context.fail. And one more scenario, you may want to forward or invoke another dialog from the end of the first one by calling context.forward or context.call. So simply you can end the first dialog, like the root dialog, by invoking other dialog like the items list dialog.
But what is the context? The dialog context mainly provides us with some methods that a dialog requires to save the state and communicate with these channels. The iDialog context interface comprises three interfaces: the internals.idialog stack, internals.ibot to user, and finally, internals.ibot data. Each of these interfaces offers some methods. So the ibot to user provides a post method to send the activity from the bot to the user. This ensures that the ibot data state is passed with the activity to the connector. And that's why mainly we'll be using this post function instead of the two methods we mentioned before. The ones that we mentioned before are the send to conversation and also the reply to activity. As for the iBot data interface, it provides access to the state data that is maintained by the connector. So context.user.data retrieves the user data that is not related to a specific conversation, while the private data conversation retrieves the user data that is related to a specific conversation. And finally, the conversation data retrieves general data about this conversation. The last interface, the iDialog stack, provides methods to manage the dialog, as we mentioned before.
Now let's create our first dialog. So what we are going to do is that we will work on our Hello World bot, and we will make it use the dialogs and do the same functionality by just replying with the length of the characters of the user input. But this time we'll be doing this functionality using the dialogs. You will realize that when you download the bot project template, it already adapts dialogs. That's why my template is kind of the old one. So what I'm going to do is to move from the old template to the new template, but programmatically together, so that we can understand the template, understand the adoption of the dialogs. Let's get back to our Hello World project. Here it is with the basic post function that actually calculate the length of the user input and reply with this length. So what I'm going to do is that I will create a folder here. It's a new folder, yes, and I will name it dialogs. And then I will create a new class that will represent our root dialog. So let me name it here, root dialog. It's kind of the main screen of our bot. Let me add this, yeah. And as we mentioned in the slides, this class should be decorated by the serializable attribute. So yes, that's attribute to make sure that the state will be persisted, and it also should inherit and implement the interface of the iDialog. iDialog, yes. But this will not be recognized since I didn't add the namespace of the dialog. So let me just write it here, the object, and say that I want to use the bot builders.dialog. That's the namespace. Then, as we mentioned, each dialog should start with start async method. So let's define this method by implementing the interface. So let me get here and implement this interface. Now we have the start async method, and I want this method, when the dialog starts, we should call the context dot wait to suspend the bot till it receives any message from the user. So I want to pass here as an argument the function that will be implemented or that will be invoked when this dialog is started. This method will handle and process all the messages sent by the user or received from the connector. So let me define this method. So maybe it's a private one, multi-threading with task as a return type, and let's name it message received async. This method will be invoked when a message is received and this dialog is on the top of the stack, so it will be handling most of the messages received. And as parameters, it will take iDialog context, which is our context, and as a second parameter, we can have the awaitable, which is of the type object, as the result. Good. So in the body definition, we can just write the definition that will form the reply once this message, once a message is received and this method is invoked. So let's save the receive activity in this variable. That's the activity received as a result, which is the result. Yeah. The activity sent from the user, which is as activity. This result is an activity as well. Activity, yes. And let's, before continuing this method definition, let's have this message received async as a parameter here. So what will happen once this dialog is initiated? It will suspend the bot waiting for the user input, and once the user type anything, this method will be invoked. Now I need to end this method by returning that the task is completed. Yes, and also I need to include here the namespace of the bot connector, yes, Microsoft.bot connector, to be able to recognize the activity. Now, let's get back to the message controller and take this thing which calculates the length of the user input. Let's have it here. Cut, and get back to the root dialog, and let's paste it here. Now it's the length, calculate the length, and let's modify this reply. But before doing this, I want to come back here in the message controller and define, or actually call the key method when it comes to implementing the dialogs, which is the send asynchronous. So after checking if this activity is a message, I can come here and say just await, since it's async method conversation. If you remember, we talked about the send async method, and we call send async just here, send async yes, and I will pass the activity. Maybe it cannot recognize it since need the namespace. The dialog is 1. Now it can recognize it, and I will pass two things: the activity that I just received from the post function, in addition to the dialog to be initiated, which is the root dialog. New dialogs I have here dot root dialog. That's the dialog I have, and that's what I will write in this message controller. Let me first add this bracket to have the right syntax. Now it's okay. Let's get back. That's the definition, the new definition of the post function while adapting the dialog. Let's get back to the root dialog and say here that I will not use this create reply message. I will use the context.post. So I say here await.context.post. I think if you remember this method, the one we talked about in the slides, and I can post the new reply. Again, each dialog should end by context dot either wait, so that you can suspend the bot waiting for the user input, or can you say I'm just done and I wanted to close this dialog and remove it from the stack, or maybe you can invoke other dialog as we are going to see in the next demos. Now we have the same bot doing the same functionality, which is calculating the length but adapting the bot. From this you can maintain the conversation flow, invokes more dialogues, and maintain a real conversation as a real world bot. Again, before running this bot, as you see here, you are using the post async, so we guarantee that the state data will be persisted and passed with the activity to the connector. So let's run this and make sure that it's running. And just a reminder, when you download the new template, you will find that it has the dialogues already in place and the root dialog. So you don't need to do all of this stuff. I just made it with you step by step to have a solid understanding of the dialogues. Let's connect again and say hi for this bot that adapts the dialogues. Now it's replying as well, but with the dialogues in place.
So we just created our first dialog. One more thing that's worth mentioning about the Bot Builder SDK, that it provides you with a set of prompts that you can use to simplify collecting the input from the user while you develop your bot. These built-in prompts are implemented as dialogues, so they are like sub-dialogues that have their own state. The prompt dialogues actually have 5 types. So the first one is choice. So just a set of choices where the user can select one of them. Another type is confirm. So that will prompt the user or wait for the user to say either a yes or a no to one of the questions you asked. Also an attachment. So the user here can have an attachment in his reply, or a number. So also just any number, like 12 maybe, or so it's either a double or a long. And finally a text, so just a simple string from the user as a prompt as well.
So let's try one of the prompt dialogues. Let me get back to my Visual Studio, stop this running solution. Now, for example, if I can get back to this message received async, and I want to try the confirm prompt dialog. So I can put a condition here. Let me remove this one. And I will say if the activity dot text, which is the input of the user, for example, is okay, I can ask the user to confirm using a prompt dialog. Sorry for this, let me remove it. Prompt dialog dot confirm. So this method expects different parameters. The first one is the context. Yes. The second one is the message to be invoked when the user answers with yes or no. Let's skip it for now. We are going to define it. The third one is the question, the prompt itself, the string prompt. So for example, we can say, are you sure? That's the message that the bot will send. Maybe if the user didn't reply with yes or no, we can have here an error message. So maybe the bot can reply with didn't get that, as it will still wait for the user to reply with yes or no. And the last thing is the prompt style. I can add it here, find here, yes, the prompt style. Maybe the prompt has different styles that we can use, but we can say here that we don't use any of these styles for now. And our next step is to start defining the method that's expected here as a second parameter to be executed after the user confirms with yes or no. So let's name this method after okay. I think, yeah, that's what we'll name our method to be implemented when the prompt appears. So we can go here for defining this method by saying public, and it's an asynchronous thing, task, and we have this after okay as thing as the name of the method, and it has here two parameters, the iDialog context, which is our context. Also, it has the result or the argument. Maybe I can go, not the result here, it's the argument mainly. So I can go for Boolean as it's yes or no. Yes, let's go for, that's the declaration of the method. Let's go for the body of the method. I can have a variable, which is the confirmation variable. This variable is confirm, and it has the yes or the no of this user input, which is the argument. Yes. So if confirm is true, you can easily post replying to the user by using the context.postAsync, saying, okay, I will proceed, for example. If not, I can say to the user other thing like I will not proceed, or maybe any other reply that makes sense to the scenario that you are building. So maybe just neglected. Yeah, as a response. And then again, when this method is invoked, I need to still suspend the bot to wait for the input of the user and make the coming inputs handled by the message received asynchronous method, the one we just created here. So let's try running this and see what will happen. But I think we don't need this anymore, as we already have the prompt dialog. We are not calculating the length of the input anymore. But before running this, let me comment this context.wait, as we're already having one invoke here that will suspend the bot to receive the user input once this after okay async method is invoked. Now let me run this and get back to the emulator, connect. And the point here is that if we want to have this prompt invoked, we just have to write okay. As you see, we're putting a condition here. If the activity.text, which is the user input, is okay, the prompt should be executed and ask me the question, which is, are you sure? So I just typed okay, and now it's, are you sure? So if I typed yes, it will reply with okay, I will proceed. Other than that, it will reply with just neglected. But if you see, are you sure, it's just a question that's very generic that may mislead the user. So if you want to make it more specific, you can change the prompt style to, for example, show the yes or no per line. So if we just change it, this style, and we run the solution one more time, and we have this connecting again, saying okay. So what will happen is the prompt will be executed, but the yes or no will appear per line as we change the prompt style. And that's a quick example of using the prompt dialogues with the confirm type. Definitely there are a lot of types that you can use. Feel free to fiddle with any of the prompt dialog types.
So we just saw how to create our first dialogue and also how to use the prompt dialogues. Now let's see how we can manage our conversation flow using multiple dialogues. So I have a project here with firstly the root dialogue, the one you saw in the previous project. And I've created two more dialogues. The first one is the course dialogue, and the second one is the next module dialogue. So in order to go from the root dialogue to the first dialogue, which is the course one, I have to go back to the root dialogue here and call this specific dialogue. I will use the context.call method. What this does, it invokes another dialogue and it will add it on top of the stack. So here I will invoke the course dialogue. And then, so now the course dialogue is added on top of the stack. So let's just have a look at what the course dialogue does. It will just run these specific functionalities. And then once it comes here, as you can see, there is context.done. What this does is it will remove this course dialogue from the stack. So if we come back here, I need to have another method to be invoked. So once this course dialogue is removed from the stack, it can run this functionality. So let me just add this here. And then let's create another method that will be used after the course dialogue is done. But in this case, we will, let's call it, for example, course dialogue resume after. And we need to have this method back here. So this will be invoked after the course dialogue is done. So I'm just going to say this dot course dialogue resume after. And now for this, this specific method, the course dialogue will return with a string. So I will not be using the iMessage activity. Instead, I'm just going to use just a string instead. And here we want this, since I have more than just one dialogue, I want this after it goes to the course dialogue and it comes back here and this course dialogue is removed. I want this method to go and actually call the next module dialogue. I think it seems that I've just missed a semicolon here. Now, in this method, I just wanted to, as I said, go back to the next module. So I'm just going to do the same thing. Let's just call again the next dialogue. So instead of having it as course dialogue, I will use the next module. And same as this one, it will go to the next module and invoke this dialogue and add it to the stack. And also here, it will, once it hits done, it will remove it from the stack and come back to the root dialogue. And this is where I want to see, for example, some message sent to the user to show him that you've done some action here. So let's say, let me just put this between a try and catch clause. And then once it hits here, let's say, for example, that I want to show the user a specific message. So I'm going to say here, and instead of saying, hey there, Mr. Bot, I'm just going to say, for example, sorry, I don't understand that. So I called the next module dialogue. I just also need to invoke another method here. So I'm going to do a similar method here, and let's just call it, instead of course dialog, let's say next module resume after. I think I missed it. And then go back here and just say that once you're done with this, go to next module, resume after. And here I don't want to call another dialogue. I just want it to end and show me that I've actually reached the end, just the end of this whole conversation flow. So at the end here, let me just say, for example, great, you have reached end of the second dialogue. So before I run, let me just add this one more bracket that I'm missing. And then also, I will add some breakpoints so we can see what's happening while we're running. So let me add one here. So once it calls this next dialogue, and once it receives the message from the user, and also once this is done, so once I say yes, it will go through the context.done. Let me see where else. We can also put it here where it calls the next dialogue, and same for this one. Have it when it receives the message. And then finally, when it, if we don't say yes, so let's try not saying this yes this time. So it's gonna go also, I think go here, perfect. And finally, when it goes all the way to the end and it just stops in the final method here. Now let's run and see what happens. Awesome, it's running. Let's connect to the emulator. It's this localhost. So let's, awesome, it's connected. Let's say hi. As you can see, it stopped here. So once it received the message, it said, hi there, I'm Mr. Bot. And it now will start invoking the next dialogue, which is the course dialogue. So if we go here, it will actually start telling us, do you like this course? And suspend the bot and wait for a message from the user. So let's press continue. Go back to the emulator. As you can see, it says, do you like this course? It stopped here as it was waiting for the message from the user. And then let's press continue one more time. Let's say yes. So now it stopped here. As you can see, it's waiting to send this message and then say that this dialogue is done. Let's remove it from the stack. So as you can see here, it says, awesome, we're glad you do. Let's continue again. Now it's going to call the next module dialog, and if you see here, it will ask me another question. So let's press continue. So will you watch our next module, guys? Let's say you guys say maybe. Before we do that, let's just press continue again, and then send this. It also stopped here. It didn't go through the yes because I said something else. I said maybe, and now I should see, we hope to see you there one day. Awesome, it's right there. Let's press continue one more time. And now it should give me the final message where it says, great, you have reached the end of the second dialogue. So let's continue one more time. And that's perfect. So this is the end of it. And as you can see, you now saw the whole conversation flow of creating multiple dialogues and how you can test them out and see how they run.
Okay, great. So we just saw how powerful the dialogues are when it comes to managing the flow of the conversation. Now let's talk about managing the state data. As we mentioned at the beginning of this module, the Bot Builder SDK enables your bot to be stateless. However, sometimes you need to store the user's preference maybe to customize the conversation at the next time or to greet a returning user. So the state client object enables you to manage the state data, store it, so that you can use it to customize the next conversations with the user. As you see here in this code snippet, it defines an object of the class state client, and then it uses the methods under this state client, like get user data, get the conversation data, get the private conversation data, the methods that we mentioned before, and we can store this data for further usage.
Let's move to another important feature of the Bot Builder SDK, which is the form flow. As you saw, dialogues are very powerful and flexible, but when it comes to managing a completely guided conversation, there can be a lot of effort. Using the form flow automatically generates dialogues that are necessary to manage a guided conversation. Like any form, you have to define fields for the data so you can collect the needed information from the user. These fields can be either defined through creating a C# class or a JSON schema. And the properties defined under one of either the C# class or the JSON schema must be one of these types. So it's either an integral, an enumeration, string data type, or a floating point, or finally a list of enumerations.
Let's create our first form flow generated dialog. So I'll get back to my Visual Studio, create a new project. Yeah, let me create this project and name it form flow hello. Yeah. So in this project, we simply will do a basic form that allows the user to pick the t-shirt size and the t-shirt color. So we'll be using the form flow to automatically generate the dialogues that help us to have this guided conversation. So I will start by creating the form itself, where all the choices are included in a C# class, the fields, where it includes the data that I expect to collect from the users. Then I will load this form from the controllers, as we are going to see, but let me start here by creating a new folder that will contain all the forms that I'm going to create. I will just have one form. So let me create a new folder here and name it forms. And I already have here on the desktop, I have the class that includes the form and the choices and the fields. Let me include it to the project and explore it. Now it has two enumerations, the size options, small, medium, large, and the color options for the t-shirts. That are the options that the user will pick from while ordering his t-shirt. And then I have the form itself, as you see, with size option and color options, and it has one method which is build the form with this message, and it calls the build method to form or to build the form to be visible for the user. Let's get back here to our controller and remove this one. Yes, and start having a method that will form our first form flow, or the form flow generated dialog. So I will go here and create one more method. It acts like the root dialog for me. Then I will refer this method from the post function to form the first form we have in this demo. I will start defining this method, as a static method. Yes, let's have the iDialog as the return type, and it will work on the form of pick your t-shirt. Then let's name it make road dialog. This method will simply build our first form, the basic one with the choices to pick the t-shirts with the size and the color. And while you can explicitly manage the stack of the active dialogues by using methods like call and done, you can also implicitly manage the stack of the active dialogues by using chain method like this. So if you see here in the chain, it uses the form dialog, then from form, and it calls the build form method that we have in the pick t-shirt form, and then it actually posts just took your order when the form is completed. Let's run this and try it And let's see, after running this and try it, what will happen if the user is stuck in any of the choices, or if the user just decided to quit the form. We need to handle this. So let's run this, try it, and then we can do the exception handling. But before running this, let me first redirect from the post function to the root dialog, the one that includes our form flow. So I will use the same function, which is under the class conversation, the send async function, to redirect to the first dialog that includes our form flow. So I pass the activity and call the make root dialog. Now I don't want this line anymore, as I don't want to reply. I just want to redirect to the make root dialog. Then I will hit here to run my solution. While this is happening, I still have the emulator to test and debug. Once it's done and it's running on the local server, we can start experimenting our first form flow with the basic fields like the t-shirt color and size. Now the build is succeeded. Yes, so I think it's running now. Good. Let me have this. Let me check the localhost. Yeah, same. Okay, so I can hit connect and try chatting with the bot and seeing the form flow. So here we go. As you see, it loaded the form by the message welcome to the simple pick your t-shirt bot. This message is simply, if we get back to the solution explorer, it's here in the form. Once we call the build form method from here, if you can remember the build form method, and also it started asking me about the options. So I can select the size, which is medium, then I can select the color. Once the color is selected, so it's asking me, is this your selection? I can say yes. It's kind of a confirmation message. I can say yes. And then once the form is loaded, it told me just took your order. Now let's try chatting one more time, but this time we will not complete all the selection. So what will happen if I just say this to the bot and I didn't select anything? It's not a size option now, it's not, and it will stuck for this. But what is the case if the user want to quit this form? We need to handle this exception. So what we are going to do is that we'll get back to our method here, add this in a try and catch. So I can come up here, just add try and catch. So I'll take this in the try. And then when any exception happens, like any expected exception of type form cancelled exception, you can have here the form cancelled exception for the pick t-shirt form. I have this exception. I can start handling this exception in order not to make the user stuck in the form if he wants to quit. So let me define a reply first, to reply with if the user decided to cancel, and if the exception is of type, the inner exception is null, yeah, that means that the user decided to quit. So I can reply to the user saying you actually quit on a specific question in the form. Maybe I can have it here on the last thing. Yes, the last thing in the form. Otherwise, I can say that anything else happened, like error, please try again, and we can start over the form. So we can form another reply here, and let's put it for us as error, please try again. For sure, when you are developing a real-world bot, try to have more friendly messages. We are just using this for demo purposes. And the last thing, I can come up here and post our reply using the context.post async, the method that you are using and it passes the persisted data with it. So let's try this and see if we write quit this time. So I'm going to run one more time, but this time I will quit, will not complete the full form. Let's wait to have this project running. Yeah, it's running now. I click connect. Now let's hit hi to this user, to this bot, and let's try hitting quit. Yeah, you quit on size. So we quit on the size form, as you see. So quit is handled and the exception is handled as well. So let's try one more time. Hi, and pass any unexpected input. Again, this is not a size option, so if you want to quit the form, you have to quit. And you can easily send to the user messages telling or informing the users that if you want to quit, just write quit, or maybe you can implement a global message handler in your bot project. You can also customize the user experience using the form flow by using one of these attributes. So for example, you can use the optional attribute to designate a field as optional, so the user doesn't have to give a value or choose one of the choices, or you may restrict the range of the allowed values of for a specific field to be a numeric value using the numeric attribute. You can also change the layout, the display layout of the field itself, or the whole form, using the prompt and the template attributes. And the terms attribute, for example, you can use this termed attribute to increase the likelihood of being able to match user input with one of the valid choices. You may use the terms attribute with a regular expression to account for the fact that the users are likely to misspell the word. And finally, you can also get use of the pattern attribute to specify the required format for the value of a particular field. Using this attribute, you can use the pattern language that we are going to talk about now. The pattern language mainly can be used to customize the prompt where the form is running. A lot of prompts is displayed to the user to pick the choices he or she wants. So you can use this pattern language to customize this prompt, or to override the default template to change the display layout of each prompt as per the field thing in the form. So as you see here, there are a lot of elements for the pattern language that, for example, you can use the ampersand operator to show the description of the current field instead of hard coding this, as we are going to see this in the demo. We can also use the OR operator to show the current choices of the specific field, and you can fiddle with all of these elements to use the pattern language for customizing the prompts of the form flow, or your form in general. Let me get back to Visual Studio to start fiddling with one or more attributes. So I can come up here. If you remember here, when the form was asking me about selecting the size, just write please select the size, which is this field. So what if I want to have other message? I can use the pattern language with the prompt attribute to define a new layout for this. So I can say, hey, prompt, and this prompt I want to have, would you please select, and then I can use the ampersand operator, sorry, it should be like this, to have the description of the field included directly. So would you please select a size for your t-shirt, and then I want to show all the options or the choices of this field, so I can use here the OR operator like this. Let me close this bracket, yeah, first. And now I can have my first prompt. I can also come here for the color field and mark it as optional, so the user doesn't have to choose this. Let's try this and run our solution. Let's open the emulator one more time. Yeah, once it's running, I can start chatting with my bot and see that the attributes are changing the display of this form, and the behavior as well, since I I used one of the optional attributes. So let me connect again and say hi and wait for the form to be loaded. Now it uses this message, welcome to the symbol pick your t-shirt bot, the one that we had, the message that we had here in the build form method, and then it used the prompt attribute to show this message, would you please select, and the ampersand here is the size for your t-shirt, and then with the OR operator I have all the choices here, so I have to pick size. Then the other question, please select a color, maybe I don't want, so I have one more option here which is no preference, since I added the optional attribute, so I can say no preference. And now is this your selection? Yes. So it just took your order. So that's how you can use the attributes to customize the user experience using the form flow. It's cool to explore the rest of the attributes to have the best user experience using form flow.
By completing this demo, we actually reached the end of this module. So if you want to read more through the documentation, you can navigate to these links. You can also go to some of the code samples on this GitHub link. You'll also find all the tools that we used, so the project template, the SDK, and the emulator. You will also find our code samples on this GitHub repo, and for the Q&A sessions and the slide decks, you can navigate to aka.ms/bot0hero. Thank you so much for watching, and hope to see you in our next module. Hi guys, welcome to the third module of developing intelligent bots from zero to hero. In this module, we will shift our focus to designing bots by covering the bot patterns. So we will be focusing on four main patterns: the task automation, the knowledge base, the bot to web, and finally the handoff to human. So now let's start with the task automation pattern. When we develop a task automation bot, we mainly offer the user a totally guided conversation. And this conversation does not rely on the natural language understanding. It actually mainly utilizes the prompt dialogues and the form flow. So mainly the task automation bot enables the user to complete either a specific task or a set of tasks. And since it's a task-oriented bot, you can either, or you want to embed this bot into your app or your website, either by using the direct line API or the web chat control. So let's see an example of the task automation pattern. So let me go back to Visual Studio. Here I have a task automation bot. With the main functionality for this bot is either for the user to recharge the credit or show the current balance, their current balance. So because of this, I have two options, the recharge option and the show balance option. So here I will be using the prompt dialog choice instead of the prompt dialog confirm that we saw in our previous module. And here I will give this function has a couple of parameters that we're going to go through. So the first one is the context. Then this is the method that will be invoked after the user selects the specific choice. Then the choices that we're going to give the user, the question, and here the question is, what do you want to do today? And then if the user doesn't give the right choice or doesn't respond, we're just going to say, sorry, I didn't get that. And finally, how many attempts can the user give? How many attempts does the user have to give the right selection? So once the user has their selection or selects one of the options, this method will be invoked, the after choice selected. And here, as you can see, there are two cases, whether if the user selects the recharge option, it's supposed to go to the recharge dialog. We don't have this implemented here, but that's where it's supposed to do it. And then if the user selects the show balance option, it should also redirect it to the show balance dialog. So you can also do the same thing using the form flows. At the end of the day, the task automation bot offers a guided conversation that enables the user to do or complete specific tasks.
Now let's move to the second pattern that we will cover in this module, which is the knowledge base pattern. The knowledge base pattern provides the user with free conversation, not like the task automation bot, just a simple or specific task that should be accomplished by the user. It's more into natural language understanding. So as you see here, here's how it goes. The bot receives a message from the user through the bot connector service, then send it to the natural language understanding service. Then the natural language understanding service replies with intents and entities. And after this, your bot have started to understand the needs of the user, and it needs to start doing some search and data source to come up with the required knowledge or the required data from the user's side. So it starts searching in a specific data source. Maybe you have different data sources that you can rely on, whether it's a SQL, MySQL, any data source you will have in your architecture. Then the search replies back with the result, and now your bot's web service is ready to create a reply that should be sent to the bot connector service, and from the bot connector service to the channel, and then to the user. So since this knowledge-based bot is providing a free-form conversation, not just a guided conversation, it should be designed carefully to understand the needs of the user so that you can be able to guide the conversation naturally based on the natural language understanding. So in order for your bot, for your knowledge-based bot to be able to provide information about the specific topics that interest the user, you may want to rely on Lewis API, the one we mentioned in Module 1, and the Bot Builder SDK provides a built-in support for Lewis, so you'll be able to use it easily. Also, you can use Azure Search, which provides search as a service, so that you can add the search functionality into your application, whether it's a bot application or mobile or web, without being an expert in the search. So let's create our first knowledge-based bot. In this demo, we'll be mainly doing an end-to-end scenario, as we will first create a database, feed this database with some data, and then create Azure Search service that searches this database and retrieves the results based on the query. And then we will develop our bot using the dialogues, and mainly prompt dialogues, to provide the users with some choices. Based on the choices, we will do the search, return the results, and create the reply. After this, we'll be replacing this prompt dialogues with Lewis dialogues. So we'll create a Lewis app, and then we'll consume this Lewis app so that we understand the natural language of the user, do the search, and retrieve the results and create the reply, so that we have the end-to-end scenario. Let me get back to my Azure subscription and start creating a resource group. This resource group will act as the container that will carry all the resources that we are going to create, like the Azure Search, the Document DB, and the cognitive services as well. So let me create a new resource group. Let's name it Chocolates Gallery. The main reason I'm naming it chocolates, as the data we will feed the database with is just like different types of chocolate. So let me add RG here to remember that it's a resource group, and hit create. Once our resource group is created, we will go for our first step, which is creating the database. So I go here, I want to create a document DB. This document DB is mainly under the Cosmos DB umbrella on Azure. So let me search here on the document DB. And in the search results, I have here Azure Cosmos DB. Provides you with different databases. You can here also create a MongoDB, but in this demo, we'll rely on the document DB. As you see here, we'll be creating document DB. Let's create it. That's the account, the Cosmos account. So let's create it chocolate gallery.documents.azure.com, and I will be using the same resource group that I just created, which is the chocolate gallery RG, and I will hit create to start creating our database. Once it's created, we'll be feeding this database with some data that I have in a JSON file. Let me see the progress now. Yeah. Once it's done, we can start feeding this database. Now I have my deployment succeeded. So if I get back here to the resource groups, let me close this. and searched on the chocolates gallery resource group, I will be able to see the document DB account, so that I want to create the database. Yeah, here's my Azure Cosmos DB account. Now let's create a new database. So if I can navigate here to the Data Explorer and add a new collection. Once it appears displayed, you can add a new collection. Maybe you can name it as Chocolate DB. Let me reopen it one more time. So here I have this account, Data Explorer, once it's loaded. Yes, here we go. Let me open it. Perfect. So I can create a new collection here, and let's name it Chocolate DB. That's the ID of the database, and the collection we can name it Chocolates Data. And let's create this so that we can start feeding this collection with data using a tool that's here I downloaded, which is the DocumentDB data migration tool. So I have on my desktop a JSON file that includes some data. So if we can open it here to see just a list in the JSON file with 3 or 4 chocolates with different types. So as you see here, each chocolate has an ID, type, name, flavor, and the URL for the image. As you see, I have 3 objects: the length, the Hershey's, and the Reese's one. So let me feed my database with this data using this tool. So the first thing is to ask me about the source information. The source of information is simply this JSON file. So if I get back here to the desktop and pick this chocolate file, now I have the source ready. As for the target should be the document DB that I just created. So I need a connection string to be able to access this document DB. Let's get back to Azure and the document DB. Here I have the keys. In the keys I can get the connection string. Yes, that's the connection string. But I think this is missing. Yeah, if I copy this, let me put it here in a notepad. This is missing the database name. So I can add this database name, which is chocolates DB, and copy it, then paste it here as a connection string, then start verifying to make sure that this tool can access. Yes, successfully connected to the document database account. So one more thing, I can just try it here, the name of the collection, which was chocolates data, and then I can proceed to the next step, the summary, and I can start importing this data to my document DB so that I can get after in my Azure portal and see the imported data. Let me hit import and see the elapsed time to transfer this JSON list and this data into the collection named chocolates data. Yeah. Okay, so I have 3 transferred. So the transfer or the data import is done successfully. So if I get back here to this one, which is the query explorer, I can query the data that now it's imported in the collection. So if I can run this query, yes, select all from the collection, I can run the query and see that the data is now important to my collection, the DB, which is the 3 chocolates with the ID and the flavor and the stuff. The next step now is to create our Azure Search service using the same resource group. So I will hit add or new, and I will search on Azure Search. Yes, good. So I just found it. Here's the search results. Should be the first result. Yes, perfect. Let me create a new one. And as we said, the Azure Search is just a search as a service solution. So I'll create one, as I will be using this and consuming this from my bot as well to search into the database after either the user click on one of the prompt dialogues, which is the first scenario that we are going to do, or after adapting Lewis and using Lewis when we understand the natural language of the user. So let me name this search chocolates search, and I'll be using the same resource group, the one I created, which is chocolates gallery resource group, and I will hit create to start creating this Azure search service. Yeah, should be validating first. Yeah, validation successful, and now the deployment is in progress. So once this search service is ready, I need to make sure that this search service knows about my database, so that when I do a search query, it goes to the database and retrieves the required data. Now our Azure search service is ready and deployment succeeded. Let me get back to our resource group, and it should be here. Yes, chocolates gallery RG, chocolates gallery resource group. I will close this one. And now I have two resources in this resource group, the Cosmos DB account that includes my document DB and the chocolate search service. So let me open the search service and start importing the data source. As you see here, I have import data, which is the data source that the search service will work on. So in that case, my data source will be my document DB. So I connect to the data source, and I should be able to find here a document DB. Yes, that's some other options that you can connect to your Azure search service as a data source. So I may go for the DB account and choose my chocolates gallery account. Yes, good. Let's name this data source chocolate. Yeah, chocolate data source. Good. And the database ID should be chocolates. Yeah, chocolates DB. Yes, and the collection should be chocolates data. Let's hit OK. And once the data source is created, I can now start creating an index. And mainly we could generate indices programmatically. In more complex use we would, but the main reason we have an index here is that your data is subject to change, so we need to be able to re-index the data. Azure Search allows you to index your data on a schedule or on demand, but for this demo we'll index once only for simplification. So now I can say here that the name should be searchable and the flavor as well, in addition to the image URL. Let's make all of them searchable, as we are going to search from our bot about this. And let's change the name of our index to be temp index, so that we can remember it. Yeah, this one doesn't accept capital letters. Okay, so let's make it temp index and hit OK. Validation successful, and the indexer now will be able to go to the next step, which is importing the data. So I can create an indexer, set temp indexer. Yeah, and that's the thing that I was telling you about, that you can run this indexer on a schedule, or maybe some advanced options to make it on demand. Let me create. And we are now done with importing the data source of the Azure Search Service, so that we can use this Azure service programmatically from our bot to search the document DB and retrieve the expected results. Now it's validating. Let's get back here and see. Yeah, Azure Search, good, successfully configured. Then maybe our next step will be to try to play with the search service from the portal before doing this programmatically. So I can go to the search explorer and search by length, for example, and click search. Here we go. We have the result with the score. we have this with the ID and the search score as well. And the main reason we just have this ID and the score without having the type and the flavor and the image URL is that if we get back to this index, our index, we'll find that we marked our fields type, name, flavor, image URL as searchable only. So the ID is retrievable, searchable, and key. So if you want this type, name, flavor, image URL be part of the result coming from the Azure Search Service, you need to make this retrievable. But unfortunately, we cannot edit the fields after created so far. So if you want to change this, we have to recreate the index. So let me delete this index, which is a temp index, and create it again. Yeah, here it's deleted. Good, so I can add the index one more time, but this time I will mark the fields as retrievable. So I will name it temp index, and the fields, yes, that's the fields I should have, but I think that should be done after importing the data. Yeah, so let me re-import the data again. Import data. Yes, that's the main reason. So I click here to connect your data with the document DB. It's the same steps that we did, but unfortunately we cannot change the fields after we create it. So I will go for chocolates gallery, chocolates source, and then the database was chocolates DB, and the collection was chocolate data, if you remember. Then I'll click OK. Yes, let's do this. Again, we can customize the target index as a next step once the sampling data is done. Yeah, the main reason we're doing this again is that we created an index with just searchable fields, and now we want them to be retrievable as well, so that we can, when we consume this search service from our bot, we can show some cards with the flavor and the image URL. So I will mark this as retrievable this time. In addition, these should be searchable. So I can mark all the fields from here as searchable and retrievable. Then let me name it temp index one more time and hit OK. And let's import the data with an indexer. Yes, maybe chocolates indexer, and it's once. Let's do it once. We can maybe in different scenarios maybe do it on demand or on a different schedule, but now for demo purpose we just want to index the data one time, and let's hit OK. Once I re-imported the data, I can create a new index. Yes, it's validating now. Let's check the state from here. Yeah, Azure Search Notification imported successfully, so I can add an index. Yeah, with this field. Yeah, I think there's no need to do this since we already created it in the steps. So I have the temp index here. Yeah, with the field searchable and retrieval. No need to do it again, as we did it as part of importing the data. Since our Azure Search Service is ready, in addition to the document DB, and the Azure Search Service is connected to the document DB, and we can retrieve the data from it using this service, let's get back to Visual Studio and start developing our bot that will consume this Azure service. So let me create a new project and click here on the bot application. Let's name it. If I get back here to this desktop, let's put it here on the desktop and name it Chocolate Gallery Bot. Once we hit OK, we'll be able to create our project that we can start developing this bot that will consume the Azure Search Service. So our project is just created. Let's go to the web.config and add some settings beside here. So I can just add 3 more settings, 3 more keys with different values related to the Azure search, so that I can send a query from this bot to the Azure search service and retrieve the results back. The first key will be named search name, and we'll get these values from the portal right now. And the second key will be the index name. I remember it was named temp index. And the last key will be the search key, and we can get it as well from the portal. So let's get back to the portal, and from our Azure search service, here's the name of the search, chocolates search. Yeah, let me copy it. Good. I have to copy this, get back here to my Visual Studio and paste it. So I have the search name, the index name. Let's get the key, and I will find the key here for the queries. Once it's loaded, I can manage the query keys and get my key. That's the key that I will add to the app settings. Let's copy it and paste it here. Now as our next step should be having a class that maps the search service. So let me add a new folder here named, yes, here's the new folder, services. Also, I want to have a class that will carry the search results. So I have here a folder named models, and those 2 classes I already prepared them. So let me drag the search result in the models folder and this Azure search services. And again, all the source code you can access it from our GitHub repo. So I put it here at the services. As the Azure search service, all what it does is that has the query string with your search name.search.windows.net and the indexes. You have the index name as well. This is coming from the app settings, and the key, you have it here from the app settings as well. That's the query string. Also, it can search by chocolate name. So we have the name passed here, and then she do the query using this query string and deserialize the results in the search result model, which is here. That's the search result. It comes with the value returned from the JSON, and this value includes our fields like the image URL, the name, the type of the chocolate, and the flavor, in addition to the ID. So let me save this. Now our next step is to start creating our dialogues to have the input from the user. We'll be doing this twice, one with prompt dialogues so that the user has some actions to search or to show all the chocolates, and then the search happens and the results is retrieved and the reply is created. Or we'll be doing this using Lewis based on the natural language understanding. So instead of the prompt dialogues, we'll be using Lewis dialogues. So let me navigate here to the dialogues, and I have also some message controller. It's basic controller, same that the old controllers that we have been using throughout the course. It just calls the conversation.send and redirects this message to the root dialog, and here's the root dialog. So we'll be changing this message received. We are not calculating the length anymore. I just want to have a prompt dialog of type choice. So I can come up here and create my first prompt dialog of type choice, as we are going to give the user 2 choices. The first one is to search by name, and the second one is to show all the chocolates. So let's create a method that will be invoked when the user choices. Maybe we can call it after prompt selection, and we have to generate it. So let's here and generate this method. Yes, generate the method, and it have this object. Let's make it string, since the choice will be a list of strings, and we have the context as well. Let's implement it later when we finish this parameters list. And let's create the list of the choices. Maybe it's a new list of strings. Let me include the namespace here. and it has two values. The first value is to show all chocolates, and the second one is to search by name. Let's close this. Yes. And the last parameter will be the message with the prompt. Maybe how can I help you? Yes, here we go. Let's close this and have our semicolon in place. So our next step is to start handling or actually implementing the after prompt selection when the user select one of the two options. So let's create a variable carrying the selected option by the user that's assigned from the result object. Yes, and let's have a switch case. Yeah, we need to make this a synchronous method to avoid this error. And let's have a switch case. In this case, we'll be checking the value of the option selected. In case it's show all chocolates. We can throw none implemented, or maybe you can just post to this conversation. Let's get context.post async a message that this dialog is not implemented yet. Let me put the await keyword and finish this case with break. Good. The other case will be the search scenario, and that's actually the scenario that we are interested in through this module to use, so that we will be directing this method to a dialog that does the search using Azure Search Service. So in case the user selected search by name, we should be redirecting this to a dialog named, that's created after named chocolate search. I already have this dialog in a file that I will drag and drop in this project after I finish. And we can have as well a function to be implemented or invoked after the option dialog. After this dialog is done and completed, removed from the stack. So let's have this as well defined and break. So I need here, in order to get rid of these errors, to have this dialog included in my project, the chocolate search dialog, in addition to implementing this method that will be invoked after the chocolates dialog is being closed and removed from our stack. Now let me get back to my desktop and have the chocolate search dialog included. Let me put it in the dialogs folder. Here's the dialog. So simply, this dialog again starts with initializing an object of type Azure Search Service, the service that we just defined here in this class. And as any dialog, it starts with the start async message and asking the user to write the name of the chocolate that he or she wants, so that we can start searching about this chocolate in our DocumentDB using Azure Search Service. And in the message received async, this again, the context.wait suspend the bot till the user writes the name of the chocolate, and then it will invoke the message received asynchronous, so we can start searching. In the search result, here all what we are going to do is using the search object that's from type Azure Search Service, and search by chocolate name, which is the message.text when the user write it, and retrieve the results here. If the results value, which is the list of the chocolates retrieved from the database, this list, if the length of this list is not equal 0, that means that we have a search result. We can start creating a hero card. This hero card will have the title from the name of the chocolate and have the image from as a card image from the image URL that are the fields of the index or the fields of our collection in the document DB, and maybe the flavor of the chocolate can be added, the subtitle, and then we'll start creating a reply and say here's the first search result. If you see the value of 0, that means we only display the first search result. So if we have different chocolates with the name length, we only here display the first one, and other than that, if the length equals 0, that means there's no chocolates found, and we can post this to the to our bot connector, so we don't have chocolates to show. Then in the first case, before after displaying this, we add the hero card as one of the attachments, if you see here, and then I add this attachment, then create the reply. And again, as any dialog, it should be ended by context dot either done, so that we close this dialog and remove it from the stack, or wait to suspend the bot waiting for more messages to be handled by this dialog. But in this case, we just want to close this dialog once the result is displayed. So let's try this this code, but before this, let's put a breakpoint here so that we can see the search result before being displayed in a hero card. So let me try this by running this project. So let me run. Yeah, build started. Once, yeah, okay, so we have build errors. Let me check what is the error. Yeah, that's because we forget actually to define this resume after option dialog. Let me first add this. Yeah, still doesn't see the chocolate search. Maybe I can just create a new chocolate search. Yeah, still the same. Yeah, here we can have the namespace included, and we still want to generate this method. So let me generate it, as it needs to be implemented. So after actually completing the chocolate search dialog, we may suspend the bot, and any message received will be handled by the message received async by the root dialog. So we may just call context.wait and refer to message received async. That's what's missing. Yes, so this one, let me clean the solution and check what's missing. Yeah, maybe I think we need here an async keyword. Yes, good. So let's keep it for now. I think it's okay. Now let's run this solution and try typing name of the chocolate, then calling Azure Search and retrieving the results. But before running, let's suspend the conversation at the right place. So we should move this context.wait from here and put it here, as simply we shouldn't suspend the conversation here, since we redirect the conversation to the prompt dialog where the choices is. So after if the user chose show all chocolates, we should post that this dialog is not implemented yet, and suspend the conversation. Other than that, if the user selected search by name, we should redirect this conversation to the chocolate search dialog. So let's try now by running this solution. Let me open the emulator. Yes, now it's running. Let's connect. Yes, yeah, we are in the right thing. Connect and start by typing hi. Again, this, yeah, now we should have this prompt dialog, show all chocolates and search by name. That's the two options that we have. And if we remember, we have a breakpoint here, not here. Actually, it's in the chocolate search dialog when the Azure Search is invoked and the search result is retrieved. So if we search it, if we just click search by name, now the dialog is invoked, and please write the name of the chocolate. So let's write the chocolate name, which is Landed. We have in the database just 3 chocolates. So if I searched by Landed, the debugger should stand here. And if we see here in the search result, I have a list of values where I just have one record retrieved, which is the length chocolate with the hazelnut flavor of type chocolate. Here's the ID and the image URL so that I can create my hero card with the title, has the name of the chocolate, the subtitle is the flavor of the chocolate, and the images. I can add card image to this card with the image URL of the chocolate. Then I create the reply by adding this hero card to the list of the attachments. Let's continue and see here. Yes, so I have, here's the first search result, which is the Lindt chocolate from my DocumentDB using Azure Search Service. So the next step will be mainly replacing this prompt dialog with some Lewis dialog to have this bot accommodating the conversation in more natural way, not in just offering some choices for the user to choose from. In order to do this, I need to create my Lewis app. So again, let's go to Lewis.ai and start creating a new Lewis app where the custom model language of this application is defined. So once we have this loaded, I can create a new app. Yes, I just need to sign in. Maybe it should cache my account, but let me give it a try. Yes, so let me sign in with this account. Yeah, let's sign again. That's my Hotmail account that I want to use for Lewis. Okay, so just sign out and sign in with different account, which is the new one. Okay, perfect. Let me type the password and hit sign in. Yeah, sorry, I missed the password. Let me type it one more time. This time should be right. Now we have been redirected to Lewis.ai, and I can create a new app, Lewis app, so that I can start defining the intents and the entities. So I will hit new app and name it Chocolate Lewis. And I will pick the endpoint, the one we used before from Azure subscription. Let me create this app. And the first step that I will do after this app is created, I will start defining two intents. One is for showing all the chocolates and one for searching the chocolates. So let me first add the intents. Let me add the first intent, which is show chocolates. Yes, that's the first one, and we may have utterance to just train it, like show me all the chocolates, maybe show me all the chocolates as one of the utterances here. Definitely to have more accurate Lewis app, you need to train it more with more data, either a batch training or you keep entering different utterances. Let's add one more intent, the one for the search. So I can come here and say search chocolates. That's the second intent. And I can have some utterances as an example for the user query, maybe find Lindt chocolate or search for Reese's chocolate. One more utterance to be saved, and then I will hit save. Then I can add some entities. The entities here, maybe the chocolate names. So I can add Reese's as an entity. One more custom entity would be Lindt. And the third one is Hershey's, since my database just have 3 chocolates. Again, you can easily create a phrase list named chocolate and have these values under this list so that when Lewis detects one of them, it treats the others the same. But for simplicity, we will just have them as 3 entities since we don't have much types as the database is small. So if I get back to search chocolates, I can say here that this Reese's is the Reese's entity and this Lindt is the Lindt entity as well. Let me save. Yes. And get to the last step, which is training the application. So I will hit train the application. To train the application with the intents and the entities and the utterances we just entered. Yeah, the training completed successfully. Now let's publish this application using the endpoint that we got from Azure as we saw in the first module. So I will hit publish. Yeah, published successfully. I can test the application using the testing console. And beside the testing console, definitely I can consume this Lewis app from my bot directly using this endpoint URL, or as we said, and as we said as well, the Bot Builder SDK provides some built-in dialogue so that I can use it directly in my application. So let me get back to Visual Studio. As you see here, let me show you the code that I already wrote for consuming and replacing the prompt dialogues with Lewis engine. So the first thing you have to do when it comes to using the built-in support of the Builder-based SDK for Lewis dialogues is to decorate your dialogues that will use Lewis by this decoration. Lewis model was here, you can set the subscription ID and the app ID, the Lewis app ID, and then see what changes that we have done. The Azure search service is still the same, and then we have this method that will be implemented, or actually not implemented, it will be invoked when the intent retrieved by this Lewis model is none. If the intent is search chocolates, I will have this activity and invoke this message received method. If the intent that detected by Lewis is show chocolates, this method will be implemented by calling the chocolates dialog. So let's try this one. But before trying this, if you see here for the search chocolates, when we detect the intent, we just try to find the entity length. So we are writing this code to make sure that if the entity detected in the user input by Lewis is length, just go here to the chocolate search, passing this length string. As you see here in the chocolate search, I have the length entity, and then start doing the search as it is, as we just did in the last part of the source code. So all the changes I have done, and that's the power of the Bot Builder SDK, is that it supports built-in decorations for having Lewis included in this source code. So I have this Lewis model with the app ID and the subscription key of Azure. I have the intents decorated where when this intent is detected, this method will be invoked, and the same. And all what I did is just I tried to find the length entity when the search chocolate intent is detected. Then I passed this string to the chocolate search dialog to do the search on the length chocolate. Now let's try this, but this time we will not be having prompt dialogues. We will be more relying on Lewis. So I started building this solution, and once it's running on the local server, I can reconnect here. Yes, let me reconnect once it's running. Yes, it's running now, so I connect. So if I said hi, this should be detected as none intent. So the reply should be no intent. So if I just say hi, yes, as you see, no intent, since Lewis detected that it's not show chocolates or search chocolates. So if I said show me all the chocolates, yeah, so chocolate list invoked, this the chocolate list dialog, and it just removed the second dialog from the dialog stack where it's here. That's the chocolate list dialog. So if I said to the bot, find length, yeah, the search chocolate dialog should be invoked. Let's start searching, and here's the first search result, and it comes with length and subtitle hazelnut, and we just remove the second dialog from the dialog stack as well, as it just get back here to this chocolate search, and posted list start searching, went to Azure search service, get the record and created the hero card, then created the reply.
So by completing this, we just saw the end-to-end scenario of how we build a knowledge-based bot that consumes the LUIS API and Azure Search. So some knowledge bots may simply aim to answer frequently asked questions. In this scenario, you can use the Q&A Maker. The Q&A Maker is under the umbrella of the Cognitive Services. It's a service that scrapes questions and answers from an existing frequently asked questions site. So you can get the best of all worlds by using the Q&A Maker, LUIS, and Azure Search. So now let's move to our third pattern, which is the bot-to-web pattern. This bot-to-web pattern is mainly used in authentication scenarios. So to start off, the bot generates a hyperlink that will redirect the user to the website. This hyperlink includes data via a query string with parameters on the target URL that specify information about the context of this conversation. So parameters like the conversation ID, the channel ID, and the user ID in this channel. Then the user clicks this hyperlink and it is redirected to the target URL within the web browser. Then the bot enters a state of awaiting communication from the website to indicate that this website flow is actually complete. The user then completes the necessary task via this web browser. So this can be an OAuth flow or any sequence of events required through the scenario at hand. So then the user completes the website flow. The website generates a magic number and instructs this user to copy the value and paste it back into the conversation with the bot. So here, then the sixth step is that the website signals the bot and that the user has completed the website flow, and it communicates this magic number back to the bot and provides any other relevant data. So for example, if you're using the OAuth flow, the website then provides an access token back to the bot. Finally, the user returns to the bot and pastes the same magic number into the chat. The bot validates this magic number, provided that the user matches the expected value, so verifying that the current user is the same user who previously clicked the hyperlink to initiate this website flow. So I recommend that you go to the samples. We've provided the link for the sample in the resources slide. You can then download the bot-auth sample and try out the bot-to-web pattern. So the last pattern that we're going to speak about is the handoff to human. So regardless of how much artificial intelligence a bot can possess, there are times when it needs to hand off this conversation to a human being. So the bot should recognize when it needs to hand off and provide the user with a clear, smooth transition to the human. So when the bot decides to transfer this control of the conversation to the human, it can inform the user that it is being transferred and puts this conversation into a waiting state until it confirms that the human agent is actually available. Then, after the agent connects to the bot begins to route the messages between the user and the agent. Although it may appear to the user and the agent that they are actually chatting directly with each other, but in this case they're not. They're exchanging these messages via the bot. So by reaching this point, we have now come to the end of the third module. This module, we've covered mainly the bot patterns. You can still find the links to the code samples and the documentation. And you can also see or find the links to all the tools that we've used, so the project template, the Bot Builder SDK, and the bot emulator. Also, you can find all the code samples that we've done throughout this course on this GitHub repo, and you can follow us on any coming Q&A sessions and find our slide decks on aka.ms/bot0hero. You can also use the same link to leave us a comment with any questions you have. Thank you so much for your time, and we hope to see you in our last module.
Hello everyone, welcome to the last module of our course Developing Intelligent Bots from Zero to Hero. In this course we'll be mainly covering Azure Bot Service, and as you see here we'll be starting with Azure Bot Service 101. It's like an introduction to what the Azure Bot Service is. Then we'll be following this by exploring the templates of the Azure Bot Service and what development tools can I use to develop my bot using Azure Bot Service. Then we will have two demos. One in the first demo, we'll create a basic bot using Azure Bot Service, and in the last demo, we will create a proactive bot using Azure Bot Service as well.
So in Module 1, we mentioned that the pillars of the Microsoft Bot Framework are the Bot Builder, the Bot Connector, and the Developer Portal. So standing on this framework, the Azure Bot Service was introduced as an integrated environment for building bots that are powered by the Microsoft Bot Framework. As we mentioned in the first module, our bot is basically a web service. So we need a place to host and deploy our bot. So by using Azure Bot Service, you're automatically going serverless, utilizing here the Azure functions. The good news here is Azure Bot Service allows your bot to scale on demand, so you can pay as you go.
And the cool thing about Azure Bot Service is that it enables you to get started quickly with the bot development by providing 5 templates. The basic template, which is relying on Azure Functions. Actually all of the templates are relying on Azure Functions, as we just mentioned, but the basic template is kind of the Echo bot, as we are going to see in the demo how to build our first basic template or the basic bot using Azure Bot Service. The second template is the form template that relies on the form flow to provide more guided conversation. And the third template is the language understanding template that creates a basic bot that mainly understands the natural language of the user using Lewis API and Lewis Dialogues, as we just saw in the previous modules how to use Lewis Dialogue, but we'll be using Lewis this time with Azure Functions as part of the Azure Bot Service umbrella. And the fourth template is the proactive template that actually creates a bot that alerts the user with specific events. So normally what we did in the previous modules that the user start chatting with the bot, and then the bot replies and the conversation goes on from here. This proactive bot is kind of the bot initiates the conversation with the user by alerting or by informing him with a specific event based on a trigger. So we'll be using some resources like Azure Queues beside the Azure Functions to have the trigger that enables the bot to start initiating the conversation. And the last template is the Q&A template, the question and answer bot. And this bot creates, this template creates a bot that of pattern knowledge base bot relying on the Q&A API as part of the Azure Cognitive Services that answers the questions of the user based on frequently asked questions.
Let's move the focus to the development tools. What are the development tools that I can use when I develop my bot using Azure Bot Service? I have two options. The first option is the Azure Editor, where you can just write code on the browser. And then the second option is just use your own IDE, like Visual Studio, as we saw in the previous modules. By default, Azure Bot Service enables you to develop your bot directly in the browser. This is done using the Azure Editor. So here you don't need a local editor or a source control. As you can see, by clicking on the test button on the right, you can have an integrated chat window that sits side by side to your Azure Editor, and it lets you test your bot as you write your code. But if you're using Azure Editor, there's one more thing you need to take into consideration, that the Azure Editor doesn't allow you to manage your files. So when I say manage your files, I mean that you can't add files, rename files, or even delete them. If you want to manage your files, you can easily download the source code for your bot and use your own IDE. You can also then set up the continuous integration, as by configuring the continuous integration, any code changes that you commit to your source control will automatically be deployed to Azure. Also, by the way, you can now debug your bot locally using the emulator, since you will have a local copy of your project on your machine. One more note here. You will no longer be able to modify the code in Azure once you configure the continuous integration.
Let's get started by creating our first bot using Azure Bot Service. In this demo, we'll be creating a basic bot. We'll be using the basic template that actually uses the echo dialogues to see how can we get started with the Azure Bot Service and set up the continuous integration. And we'll be using here GitHub for the continuous integration. So let me get back to my Visual Studio. Actually, I mean my Azure subscription, not Visual Studio, since we're creating our Azure Bot Service. So let me first create a new resource group that will contain all the resources. Yeah, by clicking here and search on the resource group. Yes, here we go. Let me give this resource group a name after just selecting it from the search result. Yes, that's it. And I will hit create. Then I will give a name for my resource group. Let's name it module 4 RG, module 4 resource group. And let me create this resource group as an empty group. Then we'll be moving to the next step, which is creating our first Azure Bot Service to be located in this resource group. So I can just get it here from the recent tab or search on it. Yes, once it's loaded, I can start fiddling with Azure Bot Service. So let's give it a name, module, or maybe basic bot, as we are going to use the Azure Bot Service basic template. Maybe just have this temp, good. And let's use the existing resource group, the one we just created, module 4 resource group, great. And I will click create. It's validating now and the name is accepted. No one took it before. So we have here the deployment in progress. Once it's done, we'll be able to start creating our first bot using the basic template. Now my deployment is succeeded, as you see here. So let me get back to the resource group, close this, and search on module 4. Yes, resource group, perfect. And we will find here that we have just one resource, which is our Azure Bot Service, as we see here. Great. In addition to this resource, I have the app service plan, since the bot service uses Azure Functions. That's under the umbrella of the app service. So I have the plan that identifies the location and the pricing tier of this app service. So let me get into my bot service and start creating our first bot using the basic template. And you see here, since if we are going to create a bot, I need to have an app ID and app password. And that's the cool thing about the Azure Bot Service, that it have everything in one place. So this is from the developer portal of the bot framework, so that I can create my app ID and app password. So if I just click here, it will take me to the developer portal if I'm already signed in with my Microsoft account, and I create a new bot, which is the basic bot temp. That's the bot, and here's the app ID. And I can generate an app password as well. So as you see, that's the application registration portal under the bot framework developer portal. So let me paste this, finish, and go back to Azure, and then paste the app password. Moving forward, I will be able to choose one of the two languages, whether it's a C# or Node.js. And then I have the 5 templates: the basic, the forum, the proactive, language understanding, then the final one, which is the Q&A. So I will go for the basic. I agree. Then I will hit create bot to start creating our first basic bot. This will take a few minutes. Once it's done and it's ready, we'll be able to explore the Azure Bot Service and what are the files that are included, how can I set up the continuous integration, what are the tabs that are included in the Azure Bot Service, so that I can develop, connect to the channels, see the analytics from the developer portal. Also, how can I change the settings of the Azure Bot Service. So it's kind of a cool place that gathers and consolidate everything that you need in one place to come up with your bot developed and ready for the users to use. Now my Azure Bot Service is created. So as you see here, I have 4 tabs. The first one is the Develop tab, the one we are here, where it includes the files of the project and the Azure Editor so that I can just write code in the browser. The other tab is the channels, so that I can connect my bot to different channels. As we saw in the first demo, we connected to Skype. After deploying to Azure API apps, we were using the Bot Builder SDK, and we deployed to Azure API apps, but this time we'll be deploying to Azure functions as we are using the Azure Bot Service, and you can easily connect to any of these channels. And the third tab is the analytics, and these insights are coming from the developer portal. As we mentioned in module 1, one of the good things or the benefits of the developer portal is that it provides you with analytics about how many users, how many messages, some cool numbers to know about your bot. And the last tab is the settings, where you can customize the bot profile, like the description. And if you see here, the messaging endpoint is already basic bot temp.azurewebsites.net API messages. As we said, by using Azure Bot Service, you are by default deploying bot to Azure. And here, if you want to include some speech recognition and the analytics as well, in addition to configuring the continuous integration and the app settings. So from the settings, you can set like a profile picture for your bot, change the display name, here's the handle of your bot, and add some description to show the user what functionality the bot mainly does. One more thing here is the test button that allows you to chat with your bot using the web chat. So and again, since already we have a messaging endpoint, running endpoint on Azure, we can start chatting with this bot either using the web chat, or we can connect directly to one of the channels. So this is a very basic echo bot that when you say anything to this bot as a user, just say welcome, and then you say hi. It's like an echo. So we will get into the files of this basic template to see what's going on to come up with this bot running, and we'll be exploring the files and how it goes with Azure functions to have this bot running. Now let's get back to the Develop tab and see the project anatomy. So we have different files here. The first file is the bot.sln, which is the Microsoft Visual Studio Solution file, in case you want to download this project and be able to run it locally. And the second file is the debug host, and in this file it simply contains the commands to load and run your bot if you used it locally. So that in case you set up the continuous integration and downloaded the project locally, this file contains some commands to load and run your bot, and you will be able as well to debug it locally. This file also contains your bot app ID and app password. And the third file is the commands.json. So this file contains the commands that actually starts the debug host file. So when you have this project downloaded, you can start the debug host in the Task Runner Explorer when you open the bot.sln file. One more file we have here is the project.json, and this file simply contains the project's NuGet references. So you can modify this file by adding new references to your project. And we have also the project.log.json, which is generated automatically, so there is no need here to modify this file. And we have two more files here, the one named function.json. Simply Azure functions, and since we are using Azure Bot Service, we are deploying to Azure functions. And Azure functions used to build serverless APIs and respond to webhooks. And in order to do this, it provides two types of binding. An HTTP trigger that lets you invoke this function with an HTTP request, and this can be customized to respond to a specific webhooks. And the second type of bindings is the HTTP output binding that allows you to respond to the request. So in this file, we have the bindings here defined of the Azure functions, that actually are using in this Azure Bot Service. One more file that we are having is the host.json. This actually contains the metadata the metadata that contains the global configuration options that affects the function we are having. Now let's walk through the code, and we have two C# classes here, the run and the echo dialogues, two C# scripts. So let's have a look on the run one. So when a user posts a messages, it's sent to the run method as an activity. And the bot reacts to an incoming activity by first attempting to authenticate this request. If the authentication failed, as you see here, the bot responds with not unauthorized. And if the request validation succeeded, as here, the bot this function starts to detect what type of activity is received. As we mentioned in module 2, we have different types for the activity, like the message, the conversation update, the ping, and different types. So if the type of the activity received is of conversation update type, that means that the user is added to the conversation. So as if you remember in the module 2, we say that the conversation update reflects that the bot or any other member has been added to the conversation. So let me tell you how it goes. When the first message is, actually the first message that been sent from the channel to this bot service is normally of type conversation update. It's not a message, I mean the activity. The first activity that the channel sends to the bot is of type conversation update to specify the users that are added to the conversation. So if you see here, after having the service URL of the connector client, that's the code that we are used to see. So it checks if there are any members added to this conversation based on the update coming from the channel to the bot, and then it creates a reply with the ID of the user, and then it starts looping in case we have more than one user joining the conversation. As we mentioned in module 2, the conversation may be a group conversation, not just a one-to-one conversation, and then it replies with a welcome, then the name of this user, as we just saw here, welcome you. Since I'm using the web chat, I'm not signed in, so it just stayed welcome you. But if I'm using a real channel like Skype, it will reply with my username on Skype saying welcome Sharif. And that's in case the activity received is of type conversation update. And normally that's the first message that the channel sends to the bot. But if the activity received is of type message, this run method invokes the echo dialog and redirects the conversation to the echo dialog, the one that we are having here. As you see, that's the dialog that does the echo attitude, like you said hi, you said any other text. So it just reply with the same message that the user sent. And as you see, it's a basic dialog that starts with a start async method, then suspend the conversation till the user send any message, and when the user send any message, the message received method is invoked here, as you see. So if the user said reset, it opens a prompt dialog with confirm type, are you sure to reset? And then we are calling here the after reset asynchronous. So if the result of the confirmation is yes, so the reset will happen. And if the user replied with no, it will not reset the count. Other than that, it just posts back that the count, which is 1, and you said the text that the user sent. So it's a basic dialog that ends with suspending the bot to receive messages. That means since this dialog ends with context.wait, that means that this dialog will be staying on the top of the stack and handling all the coming messages from the user. And if you realize here, since we mentioned that the bots are stateless, so we have this count will be increasing every time we send messages to the user. So I may hi again, you'll find here that the count will be 2, since the post async method persists the data in the iBot data bag and takes it to the channel. That was part of the state management that we covered in module 2. However, if you see here the prompt dialog, it's another dialog that has its own state. So the state of the count here is different than the state of the dialog, echo dialog with this count. So let me give you an example. So I've just reset. It will reply with "Are you sure?" So I'm sure. Yes. So reset count has different state of this variable, and the prompt dialog is invoked. So since it's a sub-dialog, as we mentioned in module 2, the prompt dialogs are like the sub-dialogs that help us collect data from the user, so it has its own state. Now let's download a local copy of this project to my machine and configure the continuous integration. So let me download this file. So I click here to download my source code. Now it's downloaded. It was super fast. Let me open the folder, yes, here, and take this one and put it in a new folder named module 4 demo. Then I have my source code. Let me extract it to see the files. As you see, that are the same files that we have, the bot.sln, commands, host, debug, and everything, so that I can open my project in Visual Studio, and I can as well debug it locally using the emulator, same as we did in the previous modules. So now let me open Visual Studio and see the same files and same project in Visual Studio, not Azure Editor. Again, if we set up the continuous integration, we'll not be able to modify the files in the Azure Editor again. And here's the project. It's kind of a different project with different anatomy than the one we created before, since we are using Azure functions. So it's just a function, not like the previous projects. And we have the files here. Here's the run method that once the function is triggered, and the bot received the first message, this method is being invoked, and again it authenticates. Then it either redirect us to the echo dialog, or have received the conversation update, the first conversation update from the channel. Now let's set up the continuous integration. So let me open GitHub Desktop. You can download this from the link we had in the resources slides, and we mentioned in the first module that we'll be using this. So I can start creating a new repo. It's a local repository. Let me change the path, come here, select a new folder, repo. Let's name it like this, and select this folder. And we can name this repository as basic template using Azure ES bot service. We can initialize it with a README file and create this repository. So we have this repository created, and we have just one branch, which is the master branch. Definitely you can, if you are developing a real bot, you can start creating different branches so that you can commit to these branches and be able to control the checkpoints of your project development cycle. But for now, for demo purpose, I will be committing to the master branch. Let me first get back to the project, since we have the repository here, and have these files copied in the repo. Yes, replace the file. Okay, that's the README one. Then get back to GitHub Desktop. I should be able to see that we have 11 changed files, and I can start committing and doing my first commit to the master. Maybe this commit named adding the project source code, and as a description, the basic template using Azure bot service. Then let me commit this to the master, and I'll be synchronizing to the remote, which is the GitHub. But before this, I can publish the repo. So I can just click commit here to the local repo, then publish this repository to my GitHub account. let me publish. But before this, since I don't have a paid account on GitHub, I will make it public, not a private, so I can publish the repo. I think once I click publish like this, it should ask me to log into my GitHub account. So yes, or maybe I'm already logged in. So it will start publishing this, and let's fetch this origin. Yeah. Now let me go to my GitHub account to check if the repo has been published or not. So let's go to github.com and navigate to my account. Yes, and I have this basic template AzureBot service repo just being pushed. So as you see, and it includes the files of my project. Here's the README of the downloaded copy from AzureBot service. As you see, the name basic template AzureBot service. That's the one we just created. Now the repo is published to GitHub, and whenever I do changes, I can commit it. And from this commit, I want to have the deployment source of my AzureBot service as this GitHub repo. And that's what we are going to do now. So let me get back to Azure, and in setting or configuring the continuous integration, yes, I should be able to change the deployment setup. Yeah, here's the deployment, and I choose GitHub as my deployment source. So if I clicked here on GitHub, yes, perfect, that's the source. Then it's loading if there are any other fields that I should fill. Yes, here we go. So the authorization is my account, it's the personal account. The main reason that it detects my account that simply I logged in before. I can now choose a project to be the source. So we will go for the basic template AzureBot service, and I can choose a branch as well since we just have the master branch. So I will leave it like this, then click OK to add this GitHub repo as the deployment source for my AzureBot service. Now it's successfully set up and there's no deployments found. Now as you see, just got unloaded the only commit that I did, which is adding the project source code basic template using AzureBot service. That's the one we did, and that's the active deployment. So if we want to have a small test, yeah, this was run for 5 seconds, and that's what the only commit we had to, and it's deploying to our AzureBot service, which is the basic bot temp that relies on Azure Functions. Now let's do a simple test. Let's say that we want to change this welcome and change it with any other text by changing the files local, do a commit and see how the continuous integration, the continuous deployment will take place. So if I can get back here to my echo dialog, and let's say that we want to change this. I think this wasn't in the echo dialog. Maybe it's here. Yes, it's the run. The welcome message is in the run. So I can change it from just saying welcome to yes, to say welcome welcome, and we are testing the CI CD, the continuous integration, the continuous deployment. Definitely it's not a good practice to just have the master branch and whenever you commit it goes to deploy. It's better to have different deployment environments, and you can swap from this deployment slots like the staging and the production. But for demo purpose, we are just testing the end-to-end scenario. So I have this file, change it, and if I get back here to my GitHub, I should be able to see the changes once it happens, or maybe I can do it from here since the GitHub didn't reflect yet, just in case the get command and prompt tools are installed. So let's get back to GitHub to see if it's reflected. Yes, great. Now we have some changes, which is the text that we are going to reply with. Here you go. It was welcome, now it's welcome testing the CI CD. So let me do this commit. Maybe say modifying greeting message to test the CI CD. Let's commit to master, and push to the GitHub. And let's see in Azure deployments if we, once this is done, yeah, good. So I can see here this change in GitHub if I refreshed. Yeah, modifying greeting message just now. And if I synchronized to see the deployment, should be able to have the new deployment in place in the stack. Yes, now here we go, modifying greeting message to test CI/CD, and this is the active deployment. This one is now inactive. So if we try to say hi to this bot again now, since we are deploying to the production environment, let me say hi. Yeah, let me close this. You said hi. Yeah, since it's not the first message, I need to close this and run it again since it's not the first message. So the echo bot now is in the top of the stack. Now I want to reopen the bot to have the run method executed, which where we did the change. So let me test this and say hi. Yeah, welcome testing CI/CD, and as you see here, the deployment source was GitHub. So once we committed a new change to GitHub, it's now reflecting and deploying to the Azure functions and the Azure bot service. Again, it's not the best practice to just deploy to your live environment. Once you commit a thing, you should have branches and you should have different release environment like the staging and testing and production, and you can easily do this using Visual Studio Team Services.
We just completed our first demo in this module where we built our first basic bot using the Azure bot service, and we also configured the continuous integration using GitHub. Please feel free to build on top of this template to accommodate your bot scenario.
Now let's move to explore one more template, which is the proactive template. So in the previous modules and all the bots that we worked on, the normal behavior was that the user start communicating with the bot and just creating replies when the user initiate anything. But the proactive bot is a little bit different, as the bot is the one who initiates the conversation with the user. So for example, assume that you are building a bot that orders Uber. So you need the bot to alert the user once the Uber driver arrives. So the bot proactively sends a message to the user, notifying the user that your Uber driver is here. So as you see in this diagram, this diagram mainly shows you how the proactive bot template works. So you will notice that we have different resources here. So when you create the bot of the proactive bot template, you have an Azure queue, one more Azure function, the one named the queue trigger, beside your Azure bot app in the resource group you have for this Azure bot. So let's see how it works step by step. The first step is that the user sends a message to the bot framework servers, and this message goes from the bot connector to your bot app as a step 2, and then the message is stored in the Azure queue. So the Azure queue here is one of the resources we will have in the resource group when we create an Azure bot using the proactive bot, and the queue will be mainly carrying the messages when it's received from the user at this step. Then the message or the bot sends the message to the user through the bot framework servers or the bot connector, notifying the user that the message has been queued. And after this, the queue trigger function is automatically triggered. Once the message is added to the queue, the function is automatically triggered. And in step 6, the message is then removed from the queue and sent back to the bot from the queue trigger function to the bot framework servers or to the bot connector using the direct line API. Here is the communication between the queue trigger function and the bot is being done through the direct line API. And finally, the bot receives the message from the trigger function and sends a proactive message to the user, notifying the user that the message has been removed from the queue, And that's the whole thing how the proactive bot template works. You can actually see this diagram from the documentation on dev.botframework.com under the Develop Your Bot with Azure Bot Service tab. So you can have it and get back to it for your reference and read more about the workflow of this template. Now let's see how can we create our first proactive bot using Azure Bot Service.
Let's start our second demo. Let's go back to my Azure subscription. I'm going to do the same thing that we did for the first demo, but instead I'm going to be using a different template, which is the proactive bot template. So I'm going to create a resource group by clicking here, the new. Then, as you can see, I've actually created multiple resource groups, so I have it here in the recent. So I'm just going to go through here. Let's name it proactive bot resource group, then click create. Once it's created, we'll then add the bot service to it. As you can see, it's done now. Let's go to all the resource groups and find the right one that we just created. Let me filter here. So let's type proactive bot resource group here. And now let's add the bot service, Azure Bot Service. Exactly this one. Once we get it here, let's create it. Click create. And now we will just give it also a name. So let's still call it proactive bot. Let's say proactive bot temp, for example. This one through. Same subscription using the existing resource group that we just created, and then let's click create. As you can see now, my deployment has succeeded. So let's go back to the resource group. And we should get now, let me just close this. If we refresh, now we actually have the bot service ready. Let's go here and actually choose the proactive template. So once this opens, and also before choosing the template, we have to create again the app ID and app password. Let me do that now. Just create the app ID and password. Once it's created, I'll just also create the password. Let me copy this so I can put it back into the portal here. Paste it. We're going to still use the C# language, and finally select here the template. So I selected the proactive template. Let me just finally agree and then create my first proactive bot. So now the bot is actually created. As you can see here, these are all the files within the bot. But before we go through the anatomy of this project, let us just go back to the resource group and refresh and see what are the resources that are different from the basic bot. So we have the storage account, which has the queue that carries the messages. We also have the Azure function, which is the trigger function. And we have the bot. So to see the workflow, let's explore firstly the bot itself. So once this loads, let's see the workflow and what happens when the user first starts to send a message. So if I go here to the basic proactive echo dialog, and we go here in the message received async method, you'll see if the user doesn't actually say reset, it will go here and it will create an object that relates to the conversation reference, and it will add this message to a queue. And then it will, after it adds it to the queue, it will just tell the user that you said this message that's added to the queue and just a confirmation message that's actually successfully added. So once this is executed and the message is added to the queue, it will trigger the queue trigger function. So let us go and see what happens there. Let me just close here and go and navigate to here, the Azure function, the trigger function we have. So as you can see here, we only have one function. So if I go here, let's see what this function does. Basically, we have this trigger function, and it just, once the message is added to the queue, it removes this message from the queue and sends it back to the bot. That's why in the function configuration file, so if we open that up here, we have two bindings. The input binding, which is of type queueTrigger, and the output binding, which is of type bot, that goes, actually sends the message to the bot. So if we get back to our bot here, let me just go back here and open the bot again. And we go to the run class. Once this opens, within the run class, and I will show you this right now. So if I go here, the run class, and scroll a bit down here, you will see that if here it is filtering, and if the activity it's receiving is of type trigger, it will just reply back to the user and say that it is this activity is actually coming from the trigger. So let's test this out. I'm just gonna click the test here, and let's say hi to the bot. So what this does, it's gonna add this message to the queue, and this will trigger the queue trigger function. And once it triggers this function, it will remove the message from the queue and then send it back to the bot. So we should then receive a message saying that it's actually coming from this trigger. And also, as you can see here, it's logging and saying here that, for example, if this is triggered, it's just now sending it back to the bot. And we should receive a message here just saying that it's actually finally triggered. So let's just wait for this one to appear here. But till that comes, you can see that the function is completed successfully. All the things that we did are actually logged here, and you can see all the IDs of what we were actually doing. So let's just wait out, and as you can see here, we got the message that this is actually coming from the trigger, and also the message that we actually inputted.
And by completing this demo, we just reached the end of our module, the last module of this course, where we covered the Azure Bot Service, and you can easily find more resources about this service, the Azure Bot Service here, and this links, the documentations, the templates, and you can read more about the continuous integration. And still, you can download the Bot Emulator and the Bot Builder SDK if you decided to download your project locally and start working on it. You can also find all the code samples of the course here on this GitHub repo, github.com/SharifAlMahdi bots from zero to hero. You can find all the code samples that we went through in the previous modules, in addition to the slide decks and any upcoming Q&A sessions on aka.ms/bots0hero. And you can use the same link to post any question that you have. Before saying goodbye, let's wrap up this course. Throughout this course, we had 4 modules. In the first module, we had an introduction about the Microsoft Bot Framework. We got to know the main pillars of the Bot Framework, like the Bot Builder, Bot Connector, the Developer Portal. We also had the chance to try the emulator and deploy our bot to Azure API apps. Then in the second module, we had a closer look on the Bot Builder SDK for .NET, and we played with the dialogues, form flows, managing the state data. And then we moved the focus in the third module to designing the bot by covering the bot buttons. And finally, in this module, we talked about Azure Bot Service, and we saw how to use the proactive template and the basic template. Thank you for your time, and looking forward to seeing you in the next courses.